recording start, and now let me start our presentation. Okay, can you see our PowerPoint slide?
Looks good.
Looks good. Okay, thank you. So my name is Young Hoon Cho. I'm the team lead of Seoul National University Rocket Team Hanaro, and let me start our video safety review. So our table of contents will be our rocket overview, the ConOps, design overview of our subsystems, and then we'll move on to our Q&A. So our rocket overview is as shown. So, and let me pause a bit for you guys to read it, and please let me know if you got it.
Wow, that looks really good.
Oh, thank you.
Yeah, I'm very happy to see this slide since you guys had to update some stuff. So thank you.
Okay, thank you. So let me move on to our mission ConOps. So in our phase 1, before pre-flight, our rocket will stand on the launch pad. And after T plus 0, our rocket will ignite, and for 3.3 seconds, it will fly in a powered flight mode. And after motor ignition stops, it will coast for about 20 more seconds until it reaches 10,305 feet, according to our simulations. And when it reaches apogee, it will deploy its first parachute. And after its first parachute deploys, it will stabilize for about 5 seconds here at phase 5. And after phase 5, the first drogue chute will release, and it will pull out our deployable payload. And as the payload deploys, the deployment bag attached to it will pull out the second drogue chute, which is fully attached to the rocket, and the payload and the rocket will fall separately. And when the rocket reaches about 1,500 feet, the tender descender holding the main parachute will deploy, and it will continue falling until it touchdowns to the ground. Is there any questions about our ConOps?
I think the only edit that you could do to this slide to make it any better is for the drone and for the main chute, if you could put in the descent rates.
Descent rates.
Yeah, that would be helpful, because we'll need to know, is it coming down under drogue at 100 feet per second or slower or faster, and then under main, we're looking for something around 20 feet per second or less.
Well, we did try to match the rules and requirements, the DTEC requirements, and later on, our recovery team lead will explain the exact descent.
Sounds great. That's
Okay.
what that'll work.
So let's move on to the design overview. So we're using a COTS motor, an Aerotech M2400T PS, and we contacted Animal Motors. So we're going to get the rocket motor on the competition site. So that's
Make sure you work. Please make sure you work with them to have them teach you how to build the motor properly.
Okay.
If you've never built one of these before, it's very helpful to have their expertise. They've built hundreds of them, and they know how to do it without one misstep, one O-ring in the wrong spot, and your rocket turns into a very large Kato right there on the pad. So make sure you work with them on building the motor. And transporting a pre-built motor is not a horrible thing, as long as you don't seal it completely up, meaning either the forward closure or the rear closure. Just leave one or both of them off until you're ready to fly.
Okay, we'll make sure we learn as much as possible from them. Thank you. And for our avionics, we're using two types of for the avionics. We're using two Raven 4s COTS, and 2 for redundancy, and we're using 3 signals in sequence. So the first signal will deploy the payload parachute, the first stroke chute, and then the rocket drogue, and then the main chute. And for our GPS tracking, we're going to use a big red B for the rocket and another big red B for the deployable payload. So our avionics is mainly in COTS, and regardless of connected to the rocket, we're also going to put a passive payload, which is meant for communications, which is for our technology demonstration. So this SR-80 payload will not be connected to the rocket and will not be associated in any ways in deploying the payload. So this is independent of the rocket flight, and it's composed of a Raspberry Pi 4 controller, which collects IMU, barometer data, and raw data will be saved in a SD card. And in conjugate with that, we're going to use LoRa communication and YAG antenna ground station for communications. And along with the SRD passive payload, we also have a COTS passive payload, which uses Altus Metrum Telemega, which also serves as a backup telemetry communication. Are there any questions regarding of our avionics and our passive payload?
It's interesting that you are including the Altus Metrum Telemega. I mean, that is a pretty substantial avionics package right there. Usually that's used as your primary flight avionics, and you guys are using it as essentially just telemetry. You're not even, it will not be connected to any ejection charges or anything like that. I mean, it'll just go for the ride.
Yeah, it'll be just for the ride. This is our first time demonstrating communications in a rocket, high power rocket. So we're going to use this as a stepping stone for future communications in our rockets.
That'll also be I guess a backup GPS system, correct?
No, it won't be.
Oh, why wouldn't you want to use that? I mean, if you've looked at the software from the Telemega, from the Altus Metrum software, that has fabulous tracking.
We never thought of using it as a backup GPS, but since you told us it is great as a GPS, we'll use it as a GPS as well. Okay, thank you. Okay, so if it's done with our avionics, let me go on to the aerostructures part. So for the aerostructures, our main body is a COTS pre-peg GFRP tubes, 2 tubes, which the bottom one is 39.4 inch long and the top one is 55 inch long. These are COTS, so we bought them from an existing supplier here in Korea, and the inner diameter and outer diameters are here as shown. And the coupler is 11.8 inches long. And we know it's a little bit short for the required 1 caliber long side, but because the supplier only supplies these pre-designated lengths, this is the best we could have. But we did.
That's close enough. That's close enough, guys. You'll be fine.
Okay, thank you. And for our nose cone, we 3D printed a mode and then a male mode, and then used FRP to make a female mode, and use that female mode to make our nose cone. And we made 2 halves of it and attached it using wet preg method. And the shape is in LD hack shape, and the shoulder is 1 caliber compared to our rocket diameter.
That's not easy, is it, guys? That's a lot harder than most teams think.
Yeah, we originally tried to use the infusion process, but making a vacuum tight seal was really hard, and our aerostructures team lead really lost his mind.
Let me tell you, it was not a pretty sight.
Yeah, our winter break was really painful because of this.
Yeah, I'm thinking we ought to give bonus points for hot, or excuse me, SRAD nose cones, because I mean, once you do it, then you get it right. You know, you can get really good at it. But those first 3 or 4 attempts just want to pull your hair out.
Yeah. It really.
I would agree with that. And yes, Andy, we should. That's why I started doing it for our team. It is a learning curve, and once you got it, you got it. But until then, it's rough. So I get it.
Nothing's easy from the start. Okay, so for our bulkhead, we're using a sandwich panel composed of 2 FR4 sheets on the top and bottom, and in the center is a plywood core. So for our bulkhead that's connected to our rocket motor, it's 2 millimeters thick for the FR4s, and in the center it's 8 millimeters thick, the wooden plywood. And this bulkhead is attached to the inner rocket body using structural epoxy, which is a 3M DP460 white-off epoxy. And for safety, we reinforced it with additional wooden blocks. Here you can see the 3 wooden blocks. And although the motor peak thrust is 2691 newtons, we tested how much loads this bulkhead could withstand with the MTS testing device we have in our school, and the results show that this bulkhead could withstand up to more than 10,000 newtons. So we wanted to make sure this bulkhead could really withstand the rocket motor. And with this, our rocket motor assembly will look like this, with the centering rings and the bulkhead over here. And you can see the 3 pins right here. Any questions regarding our rocket, the propulsion bulkhead?
I think when we start looking at the actual rocket here in a little bit, we're going to be asking questions about, the front and rear bulkheads are, obviously we can see the pictures of those. Those look great. The little wooden reinforcement, that's fantastic. But I guess the middle 2, and I'm glad to see that you have 4 centering rings, because most teams only do 3. But very much so, need to understand how you guys were able to epoxy those in. The rods that you have going through the reinforcing rods, that's great. Especially for that motor has a lot of kick. So that makes me feel a lot stronger and safer, that we're not going to have a pass through where the motor decides to leave the rocket from the front.
So thanks for the compliment. And we'll make sure we'll answer the questions when we're at the competition site. Okay, so next on to the fins. So the fins we have 3 fins, and they are water jet cut CFRP plates. And the leading edge and trailing edge are sanded and sharpened into a hexagonal shape. You can see the dimensions in the next slide over here. And the fins are attached to the body using structural glue, and then it's reinforced by wet layer GFRP. You can I thought here in the previous slide you can see that the fins are attached to the body, and you can see the oblique color of the reinforced wet preg GFRPs, wet layer GFRPs. Okay, so back to the slide. And for our launch rail buttons, we 3D printed the launch rails that match the 1.5-inch rail, and we have one at the bottom and one slightly above the center of gravity. So we have 2 launch rail buttons, and it is reinforced with a wooden block. Both of the launch rail buttons are reinforced with the wooden blocks, so we can make sure that one of the rail buttons can support the rocket weight. Okay.
Quick question on the buttons. What material did you 3D print those out of?
Out of PACF polyamide carbon fiber, which is reinforced with carbon fiber. It's a filament which is reinforced with carbon fibers.
All right. Have you been able to test those on a 1515 rail yet?
Not yet. We are planning to test it as soon as possible.
Okay. The only concern I ever have with 3D printed versus purchasing commercial, because rail buttons cost nothing. I mean, they're usually, individually they might be a couple of bucks. So I'm always a little hesitant when teams want to go and do their own SRAD, because something will happen and it didn't print right, and all of a sudden they don't fit. And now you're either trying to sand them down or you're replacing them on site, and that's always a sort of a bad deal. Last second kind of scenario. Then we always ask the questions of what's the material, because we know that commercial rail buttons work. I mean, we have example after example of them flying without any problems. For 3D printed ones, again, if it's like PETG or any of the other normal filaments, there have been concerns and questions about the rail buttons splitting in half halfway down the rail. So had problems with those. Yours sound pretty strong. So, again, we just don't have any experience with that as a rail button material. So that can bring up questions during your range safety inspection. Then we're trying to avoid any of those questions. So again, I don't know. It could be too late to order commercial rail buttons at this point, but you can get those from Animal Motor Works on site if you have to change them. But we will have a section of 1515 rail during the inspections on Monday, and we will be essentially trying to lift your rocket. We'll put the rail through your buttons, and then we'll try to lift the entire rocket with that to ensure that those buttons are strong enough. So we'll see how that plays out, and if they do request that you change them, you can contact Animal Motor Works there on site and purchase some from them.
Well, this looks like good points, and I think it's just better off to buy commercial rail buttons on site, as you said. So, yeah, I think we should go on and buying the rail buttons instead. Okay, thank you
So,
for the
absolutely up to you guys, but just be thinking about it and be ready if they do ask.
We will consider the possibility of changing the rail buttons.
Okay.
So to the next slide. For aerodynamic considerations, we considered the flutter speed, the static stability, dynamic stability, and the prevention of inertial coupling. So for the flutter analysis, we used the empirical formula, and we found that our fins will flutter at Mach 1.71, and because our rocket will fly less than Mach 1, we concluded that our flutter speed is within the safe range, and the static stability is here as shown, and also the dynamic stability. Our damping ratio turned out to be between 0.05 and 0.08, and using alignment tool, we aligned our fins to be parallel to the longitudinal axis with simulation-based tolerance. So we can show you the tool we used in attaching our fins if you want to later. Okay, so are there any questions or comments about our aerodynamic considerations?
When you guys were, I guess, creating the fine edges on the leading edge of the fins, just the one comment that we've run into, we've had teams show up with literally diamond. I mean, if you rubbed your finger over the top of it, you would be bleeding by, within a few seconds. Rounded off, I mean, those things do need to be, I mean, they can be fairly pointy, but there should be no danger of anyone even accidentally falling on one and injuring themselves or cutting an arm off or something like that. So having an edge is fine, but don't put it into a situation where it's so fine that it becomes a danger.
Well,
so round them to a certain point, just to avoid any potential. Again, somebody trips at the launch pad, their hand or arm or something falls on one of those fins, there shouldn't really be any danger of them hurting themselves.
Yeah. Well, but I touched the edge and it's not that sharp, so
Okay.
I think it's okay for us.
Very good.
Okay. Okay, from now on, we're going to talk about our recovery system, and until we changed our recovery system after submitting the second progress report, so we no longer use the spring releasing mechanisms, and we
Excellent.
went to traditional pyrogenic style, and because it's a thorough part, let me introduce our recovery team lead, Luke Moon, and he will explain our recovery system.
Okay, hi, my name is Luke, and I'm the lead of the recovery system team. And our team room is very small, so we'll show it to you guys later. So as Peter told you, there was a very big problem with COTS electric lock that we tried to use until the second report, that it was actually very vulnerable to vibrations and shocks. So it had a possibility of just ejecting the nose cone in flight. So we just decided to move on to a more conventional method. So since we didn't have enough time, so we tried to use COTS parts as much as possible. And we were worried about the pyrogen flame damaging the payload and the parachute. So we separated the space of each of them. And to control the deployment timing of payload and the main parachute, we used two tender descender that both were S-rod parts. And for redundancy, we made everything two and connected to separate COTS avionics. We used Raven. Yeah. So if you have any questions during any time, you can ask me. And the table beneath is our operation scenario. So it's not that complicated as the original thing, but at apogee, the pressure increases, so the Raven sends a signal to the charges at the nose cone, and the nose cone will eject. But we were worried about the payload parachute damaging the payload while the rocket was tumbling. So we tried to put the shock to the rocket, not the payload, by a tender descender. So that is the tender descender number 1. So after 5 seconds, we thought that the rocket will be stabilized now. So that tender descender will separate and the payload will deploy and separate from the rocket. And as the rocket descends and reaches 1450 feet, the Raven sends another signal to the second tender descender, and the main parachute will deploy. Okay, the next slide. Yeah, and this is the system components of our recovery system. And as you can see, there are parachutes at the beneath of the payload bay, and the payload bay is you can see the green part of the middle of the system. And the payload is actually covered with a square tube, which is made by FR4 to prevent damage from the pyrogen and avoid tangling of other electronic lines and stuff. So yeah, and the charges are at the nose cone and the pyrogen deck, which is number 13. And we try to seal the pyrogenic part as tight as possible to ensure the ejection of the nose cone. So some parts like parachute and the polycarbonate tube are COTS parts. We ordered that commercial off the shelf, and some complex design parts are made from 3D printing. And as Peter said, it's made from polyamide and carbon fiber. So we thought it was pretty strong enough to withstand it with the regulations. And there are some parts that some parts in which is laser cutted and used epoxy resin to make strong. So at the next part. So this is the cuts part we ordered. It's mostly consists of the shock cords and parts like eye bolt and quick links. So we bought the Kevlar shock cord and the steel swivel link from Rocketman Parachutes, and it can withstand up to 950 pounds and 1,500 pounds each. And the ones we used for the shock cord, its length is 15 feet and 10 feet. And this is not the entire length of the shock cord we used in the rocket. We used several parts of the shock cord, so the entire length will be much longer than this. And the standard eye bolt and the carabiner, we think it's a bit different from the American standard parts, but we can get easily around these area because it's in metric system. So to convert to American engineering units, it can withstand up to 180 pounds and 220 pounds. And it's both made from stainless steel.
All right. Can you guys swing back real quick?
Okay.
Okay. So the carabiner that you have there, the middle image,
Yeah, it's
those will not be accepted. The challenge with those is they don't lock in place. They don't lock closed. So those are, if you just press your finger on it, it will open itself up. It's spring loaded.
Yes.
So what we're looking for standard quick links, as we call them, is a screw-on attachment where you can actually has like a nut on the end of it, and it when you unscrew the nut, it opens it up. You can attach things to it, and then you tighten it back up, and you can actually wrench tighten it so it does not come loose. So these type of carabiners that you have are inappropriate. The eye bolt that you have is fantastic. Those are exactly what we're looking for. You want single piece, non-folded. These units are called forged eye bolts. Outstanding. The other piece is your strengths. What you've designed for with your braided shock cord in the stainless steel, you guys have done sort of the same thing that a lot of other teams. You're planning for what you call a nominal flight. So all of these things will handle a nominal flight activity. And when you're designing from a safety standpoint, you have to design not for nominal. You have to design for absolutely horrible, the worst thing that could possibly happen.
Okay.
So let's run through a scenario in your mind real quick where your rocket has just ignited and launched off the pad, and something happens, and you're at maximum acceleration, and your system decides, hey, it's time to eject the parachute. So 950 pounds and 1,500 pounds, they ain't gonna cut it. And that shock cord that you have there, that is the little tiny, again, 950 pounds is a lot if you're just holding it. But if you shock it and you really hit it hard, you'll easily hit 3,000 or 4,000 pounds. And so we're telling everyone to avoid using this little tiny 950 pound strap and start looking at the 1/2 inch braided Kevlar. That stuff's phenomenal. And then the next piece is the same thing with the rotary twisty things. I've seen a lot of those fail. Those have been a weak point in a lot of scenarios. You want to make sure and beef those up as well. So I know they make one size larger, so you may want to take a look at getting those. The lengths, I think, of the shock cord look good. Typically, you're looking at having a minimum of 3 times the length of the rocket body. So from that standpoint, we're in good shape. You just want to make sure when the ejection charge takes place that there's enough shock cord to dissipate the inertia of that initial ejection. If it hits and it's like say 4 or 5 foot shot cord, and you could take that full force, Kevlar has a very interesting characteristic. Unlike say a nylon cord or some other type of polycord, Kevlar does not give at all. It doesn't flex, it doesn't stretch. When you hit its maximum length, you're done. It will transfer all the inertia, all the force directly to the attached components on each end. And that's when you got to make sure that those sections are rated up to, several thousand pounds. So, again, from that standpoint, your eye bolts, again, fantastic. That looks really good. It says it's only 180 pounds, so that thing must be really tiny. Most eye bolts, especially the larger eye bolts that are 2 or 3 inches tall, those things are rated to several thousand pounds, especially if they're stainless steel. And as strong as that one is, you want to make sure that how it attaches through your forward enclosure, that the backside is well anchored, so it doesn't just pull itself out. And then how you link the shock cords to your carabiners and to your eye bolts, we definitely want to know that as well.
Okay, we originally wanted to link the shock cord by the carabiner and the second, but I think we will make sure to upgrade all the carabiners and the shock cords that you have talked about. And
okay. If you go to the larger one, I don't know if they make them with the pre-established loops in them. So if you do have to create your own loop by tying a knot in it, we're going to take a fairly good inspection of what type of knot you're doing. How is it being secured to ensure that it doesn't work itself out halfway through the flight. But nonetheless, if you have to make your own loop, just pay particular attention to, don't tie just a couple of, generic shoelace kind of knots. Make sure you make it fairly substantial.
Okay, we'll make sure to consider the loop of the shock cord and upgrade the size of the things you have talked about. And I have a quick question about the eye bolt. The one at the third image, it was actually it was actually short for some bulkhead parts. So maybe we're considering using the one with the separate bolt part and the ring part, and you said the forged part was acceptable, so the separate part is unacceptable, right?
Right. Again, you're showing it here as the M6 M8 180-pound standard eye bolt, and most of the eye bolts I've seen are that's almost missing an extra zero.
Okay.
So if that eye bolt that you have is like a little baby one, because I really can't tell scale here. If it's like a half-inch tall, maybe that's 180 pounds. But usually the ones that are about 2 inches tall with the threaded section, those things are usually at least 1,000, if not more, from the strength side.
Okay. These things are like half-inch in diameter, and I think it's too small, so we will make sure to use it. Okay, thank you. So thank you for your feedback. And for the parachutes, the ones we are using from Rocketman Parachutes, it's COTS products. And for the payload, it's 5 feet diameter, and the drogue is 3 feet, and the main is 10 feet with the CD of 2.2. And the descent rate is in the next slide, so we'll tell you later. Yeah. So we were very concerned about the opening shock of the parachute. So we found a research by Parks College research group that showed experimental data of parachute opening shocks. So yeah, the analysis told us that the payload drogue chute will make a shock of 16 pounds and drogue 30, and the main about 100 pounds. But these numbers are based on nominal flight, so we thought it could produce more shocks. So yeah, we'll take that in mind. And the descent rate is 23 and 80 and 14 feet per second after the deployment. Yeah.
All right, Anita, what do you think about these descent rates?
Uh,
Mm, I think they're about right, at least. I mean, they're safe at drogue. I mean, it's within the standard. And the payload is also there, and main. I don't see any issues.
I'm thinking they're almost too good.
Yeah,
So
I think
let's,
they're too good. So
yeah.
I think your simulation is a little not accounting for something.
Yeah, so let's talk real quick about your payload. So the payload itself, what's the mass? This is the payload that you're entering, so it's 8.8 pounds or somewhere close to that?
yeah, it's actually not developed fully yet, but we are making it to the minimum weight of 8.8 pounds.
Okay, when I'm gonna be real careful here with my terminology. When you say it's mostly developed, so my little just sets off a little flag in my head that says we are less than a month out. We are 25 days out. Plus, you guys have a lot more significant, a significantly larger amount of travel involved. Being that you guys are on the opposite side of the planet. Anything that's not fully developed sets off a little alarm in our heads. So I won't get into the details of it, but when you're doing future Spaceport America Cups, when we get to the May timeframe, that rocket needs to be about 99% built and ready to go. You should just be doing a little fine tuning and practicing. Practice putting it together, practice putting the cases in, practice, basically building up your avionics and making sure everything turns on, and then taking it all apart again, and then put it all back together again and load it up. You want to be able to do that in the dark, blindfolded with one arm tied behind your back, because out there in the desert with the wind and all the other challenges you're going to run into, if you're doing this for the first or second time, you're going to have a nightmare. So the great teams that do well every year and often win prizes, those are the teams that practice this kind of stuff. They spend that last month preparing for walking out to the pads, literally. They know who's standing where, what's doing what, who's doing where, that kind of scenario. So if you're still working on developing parts of your rocket, you are already behind the 8 ball. Okay, enough of the speech. You guys will figure it out. But the payload itself that is ejecting. So the first question I have is, you're at 10,000 feet roughly when that payload comes out. And that payload is relatively small with an 8 to 9 pound weight. And you've got a 5-foot diameter parachute, and it's coming down at 23 feet per second.
Yes.
Let's say, for instance, we've got a 15-mile-an-hour crosswind. And you do the math in your head real quick. Where is that rocket going to land?
At the missile range, I suppose.
Probably in Texas. I'm thinking maybe Texas. We're going to have some minor challenges with that. Definitely. And does the payload by itself have its own GPS tracking system?
Yeah, it has.
Okay, excellent. That is important, but you may want to reevaluate, or you can still use the same chute, but maybe refit by taking the shroud lines and tying them off maybe halfway up, and that'll force the parachute to get smaller. Instead of having a full, you can reef the parachute, and that'll make it a quote unquote smaller parachute without having to replace it. So anyways, that's an option if you guys are interested, but quite often when you have a payload and you're ejecting it at apogee, we would like to see sort of the same kind of dual deployment scenario that you have on your main rocket, where apogee, it comes down real fast under a drogue, a controlled descent, but a faster descent, and then at 1,500 feet, something happens and it opens up. So I'm going to throw out an idea. You guys can run with it if you want to. If it's too late to mess with it, that's understandable as well. But there is a product that a lot of rocketry teams utilize, and that is called It's slipping my head. Oh God, help me, Anita. What's the I'm sorry?
Jolly Logic, I suppose.
Yeah, the Jolly Logic,
Oh,
Logic shoot
okay.
shoot release. That's what it is. For an 8-pound little payload, that might not be a bad idea.
Mm.
Just to and let me step back. Do you need the payload to have a long descent so it can collect a lot of data, or are you okay with it coming down maybe a little bit faster?
So it would be better to be a slower descent, but the more important thing is that we can retrieve it. So fast descent
Yep.
is
And so you can set the shoot release. The teams love using shoot releases for their main parachutes. And
okay.
that's where we always get upset because you can't wrap a rubber band around a 10-foot parachute. You really can't.
Yeah.
But for a 48-inch, I think that's actually the maximum recommended size for the shoot release system. And you can set it to 1,000 feet. I don't know if you can go any higher than that, but having it come down basically fluttering, you got a parachute that's fluttering. It'll come down probably, we'll say significantly faster, maybe 50 to 60 feet per second, and then have the parachute open up at 1,000 feet or 1,500 feet, wherever, and that way you get good flow data from that point. That may help avoid driving out in the White Sands Missile Range or other places. By the way, if you do, there's a mountain range where you launch, and it's about 7 miles away from the launch pads.
Okay.
If you get anywhere near that, or on that mountain range, or heaven forbid on the other side of it, that is White Sands Missile Range, and
Oh,
you will not get your rocket back. You might as well pretend like that's an ocean and it just landed in the ocean and it's gone. Because that White Sands Missile Range is a missile range. They drop bombs on it
yeah.
all day long. And so sneaking over into that area is like walking through a minefield. And that's why they just essentially tell you you're not getting the rocket back. You can, but it'll cost $40,000 or something like that. Because I mean
Oh,
that's what it takes to get it back.
yeah, we'll leave it there.
So anyways, just general ideas. Even your main coming down at 14 feet per second, that's not bad. I think we'll be more than comfortable with that. So that looks like in the numbers for a 10-foot parachute with a 50-pound rocket. Those numbers seem really, really good.
Yeah, the drag constant coefficients of the
Yep.
main was like more than twice larger than the other payload and drogue shoots. So we tried to make we tried to choose a smaller diameter with which fits with the regulations, so it has a higher drag coefficient.
What style of parachute did you guys use?
I remember it's like a shroud. It's the same
Oh, so it's the donut. It's the Iris.
Iris, yeah.
Okay, all right. So yeah, those do have fairly high coefficient of drag, but that still seems a little high to me. But I think you'll be fine. I don't think there'll be any other issues with that one. Learn how to fold that bad boy. Those donut parachutes can be very challenging because you've got, usually with normal parachutes, you've got your outer shroud lines. With the donuts, you've got outer and inner. And if you don't fold it, and there's videos on how to fold those, if you don't fold that properly, you're going to get some kind of, it looks like a donut that's been hit by a sledgehammer when it comes out, and it's not good. It's like a mess. But when they do open up, they work very, very well.
Okay, we'll work on that parachute folding thing. Thank you for your opinion. So I think that the payload 8.8 will separate from the rocket itself, so it's much lighter than the original rocket assembly.
Yep.
So I think it will be slow enough. And
okay. Yeah. Oh yeah, in fact, that certainly was not any of our concern. It's almost too slow. It was doing really good. So no, that all looks good though.
Okay, thanks. And for the manufacturing of the recovery parts, we used 3D printing and laser cutting parts. So for the 3D printing, we originally used the PLA, but we thought it was too weak and it was not good enough for the heat at the desert. So we choose the filament which is strong enough and heat resistant, and it's not bad for our health when we are printing it. So we use the polyamide, the carbon fiber reinforced polyamide filaments, and it worked pretty well. So we had to use a custom hot end Ender 6. It was somewhat hard process, but we managed to do it. So by using this 3D printing parts, we had some freedom in design, and it was easier to prototype. So these are the 3D printer. And for the load bearing parts, we thought that the 3D printer was not good enough. So we used FR4 and plywood sandwich panel. We laser cut them for a 2D shape and used epoxy resin, structural rated one to make it strong enough. So we tested it in the structural test device, and it withstand up to 6,000 newtons. I'm not sure how much that is in pounds, maybe about 3,500 pounds. So we thought it was good enough.
It looks good.
Yeah, thanks. And for the tender descender, we used S-rod tender descender, but because it was very costly and some tender descender was not able to come to Korea. Oh, yeah, thanks. Oh, the thick 6,000 newtons was 1,400 pounds. So, yeah, but we like to change that. And yeah, the tender descender, we used two models, and one we 3D printed with the carbon fiber reinforced filament and the laser cutting thing. So these are the test videos of both tender descender and oh yeah, it worked well. And the video at the left was the 3D printed tender descender, and the video at the right is video at the right, that was the FR4 tender descender. So the FR4 tender descender was smaller in size, so we are going to use that at the upper part, the number 1 tender descender. And actually we are going to use FR4 at the number 1 and number 2 tender descender. Yeah, the 3D printed thing was too large, but the FR4 isn't tested enough, so we are making both of them, but we are aiming to use the fabric reinforced plastic version of the tender descender. So do you have any questions in tender descender?
Yeah, so I guess I got a little confused when you were talking about your testing and what is actually going to happen. So, you know, tenders descenders, from my understanding, are metal. I mean, those are fairly strong structural standpoint. So you guys are I guess the final product that you guys are going to be using on your production rocket is that going to be an actual tender descender product, or is that going to be something you guys built?
Well, we are trying to use our version at the S-rod tender descender.
Okay, and that was the 3D printed product?
No, that was the laser coated fabric reinforced one. So we think it's stronger than the 3D printed one.
Right, but not as strong as the metal one from Tender Descender.
Yeah. Maybe you'll buy the commercial tender descender at the vendor at the competition. Will that be
Yeah, that might not be a bad idea to be ready for that in case they have concerns, because I've got some concerns on that one. Again, that is a critical load bearing section,
Yeah.
and yes, it's supposed to separate, but you know, you want to be real careful with that. You want to make sure that the carabiner openings that you have on one side versus the other are going to need to be a little bit larger, because I think when you move up to the next step of carabiners, they're going to be a little bit thicker. So those look like fairly small.
Yeah.
But again, that be prepared for that. So you said you guys weren't able to order those?
Yeah, it was some parts weren't able to come ship to Korea, and yeah, we had some concerns about buying them, and
Right.
yeah, but we'll try to buy some commercial tender descender at the site.
Okay.
Okay.
Yeah, and you know, the challenge though is testing. You won't be able to test it, but if you're using something that literally uses the same design
Yeah.
as the tender sender, then you should be in decent shape. But I'm always a little hesitant to be swapping out too many parts when you arrive, because the teams that notoriously run into problems are the ones that you know, said, hey, we'll just wait and get that part there on site, and then you get it and it doesn't match up with what you thought it was going to be, and you've got to do a whole bunch of what we call engineering on the spot, you know, drilling out holes or adding or redesigning systems, and that can get to be a real significant challenge. But if your design is literally identical to the existing tender descender, hopefully you won't have any problems when you get the real one. But that's still a little odd. I don't see any reason why they wouldn't be able to ship a tender descender to Korea. Rocket motor, yeah. Black powder, yeah, I understand those. But there's really not much of anything to a tender descender. I mean, it's a couple of little metal pieces, and it's a little strange.
Yeah, we'll work more on finding the products that will ship to Korea. Yeah, and the shape is the same as the commercial one, so the system will will not be that hard to adapt the commercial one, but we'll still check for the thicker carabiners. Yeah, thanks.
Yep. Okay.
Okay. So this is the schematics of the recovery system operation. So at the first step, the rocket is in the nominal flight status, and if it reaches the apogee, the pyrogenic charges in the nose cone and the pyrogen deck will fire, and it will eject the nose cone, and the nose cone will pull the drogue chute deployment back, so the drogue chute will deploy. And we were concerned about the tumbling of the rocket at this phase because it will be in sideways at the middle of the air. So we tried to prevent it from directly connected to the payload. So there will be a shorter shock cord attached to the tender descender and the rocket structure. So at the unstable phase at the apogee, it will not pull out the payload right away. And after 5 seconds, the tender descender at the top of the rocket will separate, and the drogue chute will pull out the payload and the rocket drogue chute deployment. And it will separate completely from the rocket, and the payload and the payload parachute and the rocket drogue and rocket will descend separately. And after the main chute tender descender separates, the drogue chute will pull out the main parachute. The line at the final phase of the schematics, it's a little different from the actual one, but it's connected to the main parachute deployment back, so it will work right. So is the system operation schematics okay, or do you have any questions?
Yeah, I'm just shooting this over in my mind to make sure we don't have any potential situations where you're pulling the main parachute itself. Let's say you're under drogue, your payload has already released and departed. So the scenario is that your main parachute, will that main parachute still be inside the body tube, or will it be flopping around outside?
Oh, it will be inside the rocket, the fuselage.
Okay, all right, that's good, because you want that thing to be protected. If it's outside, like the photo shows, it'll be bouncing around all over the place, and it will likely work itself free, and you don't want to main near apogee. That'll be not fun at all.
Yeah, the final
Okay, so
is after the main tender cinder separation. So the main parachute will keep inside the rocket fuselage, like the fourth image. Yeah, the one at the top.
okay, then I guess when it is released, then the drogue will have some type of gap, and it will start to fall, and then it will yank basically essentially the main parachute out of the bag, and then you'll have a main parachute with a smaller drogue even higher, I guess above it. So again, nothing potentially can interfere with the deployment of that main parachute. That's what I'm worried about.
Oh yeah, we're concerned about that too. So the drogue chute is actually connected to the carabiner at the one beneath the main parachute. So I think that after the main parachute is deployed, the drogue chute will be at the sideways of the main parachute, not the top of it. So we thought it will be less likely to interfere with the main parachute.
All right, here's the challenging question. Have you guys tested this?
Yeah, actually we did. We tested this at a dynamic environment at the top of the vehicle, and there's a video at the later slide, so we'll show it to you.
Okay, great. Yeah, I would definitely want to see that.
Yeah. Okay, so any other questions about the operation? Okay.
Anita?
No, I'm just really want to see that video too when we get there.
Oh yeah, we're very proud of the video, so we'll show it. So the next, yeah, we did tests of the recovery system for mostly two parts. The first part was the ground test. We did it at the static environment, and the second thing is the dynamic environment test that I've talked about. So we conducted more like 6 times of the recovery system, the full scale, and we learned that the sealing of the pyrogenic compartment was very critical. So if we didn't do the sealing enough, it will end up like left video.
네, 3위라고 해주세요. 3, 2, 1.
Yeah,
Yep.
yeah, it's a very tiny click, and we were very disappointed. And it was the sealing was the problem. So at the left video, we actually contain 6 grams. Like that's like 1 ounce of black powder, and the video at the right, it contains like 2/3 of the black powder from the left video, but it worked though. So we'll show you the.
네, 3, 2, 1.
Yeah. So we learned that the sealing was very critical. So we worked hard to get that sealing right.
Okay, what are you guys using for your ejection canister? Do you have like I mean, what is I guess the containment mechanism?
Oh, we used Ezra pyrogenic charges because the black powder was very difficult to get in South Korea. Actually, it's prohibited. So we made that one ourselves from the vitamin C and the
Potassium nitrate.
Yeah, potassium nitrate. Thanks. And
Y'all made your own black powder.
yeah, right. It's prohibited to get black powder at South Korea, so we had to make one ourselves.
Interesting.
Yeah, we used the recipe from the Naka rocketry, Richard Naka's Crimson powder.
Yeah, yep.
Yeah. So we'll
You
use
know,
powder in
that right there, just
Yeah.
you know, the challenge they ran into in making your own, and that could be a podium presentation.
black
You know,
powder.
just yeah, because the podium presentations that occur are sundry projects. that teams do to try to make their rocket better, different, whatever the case might be. And that would be a very interesting, because most teams in the U.S., they can just go almost anywhere and get it, and that's just the American culture, I guess.
Yeah.
And you guys are in most countries in the world are very restrictive and prohibitive on that. So it's not actually a pyrogen. I mean, are you guys? I mean, is it considered a smokeless type of thing, or is this more of a real traditional black powder?
I think it's closer to the traditional black powder. It had some smoke, but it's a reduced version of the black powder. So
Okay.
yeah, it's less dirty things. Yeah.
Okay, so what I was before I was leading to is, what is the actual container that you put the black powder in, and how do you connect the E-match to it, and how do you design that? What is that for your design?
Oh, maybe we'll show it to you guys. Peter, can you read us the charges? Yeah. So the black powder, yeah, it's in the lower shelf.
And here's the next question: how are you going to get that to the U.S., or are you going to buy black powder when you get here?
Well, taking this black powder to America was was not possible. So
Right.
and yeah, the Canadian team owners will share their black powder.
Nice.
We became very
Again,
friends. Yeah.
in the U.S., we've got 4F, which is just FFFF,
Yeah.
4F black powder. That's traditional black powder. And you will see a different type that is called pyrogen, and that is 3Fs. And that is your smokeless. And they are very different. 4F is more powerful, it's much stronger. And you don't have to worry so much about packing it tightly. You do, I mean, you should always pack it tightly. The 3F pyrogen, or known as smokeless, that is the one that if you give it a chance to I guess aerolyze or separate before you ignite it, you will get a floof. You won't get anything. You'll get a useless ejection charge. We always recommend, if you can get your hands on the 4F, that is what you should work with. That's what you should test. And so the fact that you're changing powders from what you're used to what you're going to, you guys are still planning on doing a test ejection on the site?
Yeah, of course. We'll do many ground tests at the back of our motel. So we were
No,
planning.
no. Oh God, no.
Oh no.
No. Please do not. I
Okay.
just don't need a hotel calling me up saying the kids are shooting fireworks off in the backyard.
But the motel was actually okay with the ground test at the former competition. Oh,
Did they really?
yeah. The
Oh wow. Okay, so let's not. We actually have an area specifically set up at the VLA for ground testing.
Yeah. Apologies.
Yeah. So, and you can't set anything on fire out there. You really can't hurt anything. Much better to do it out there than, you guys will be in the parking lot and a police officer drives by just at the moment you hit the button, and then, oh crap, here we
There'll be
go.
some extra stuff. Yeah. We'll make sure we won't do that. Okay. Thanks.
Okay. Yep. Well, that sounds good. Again, the container and E-match you show me that one later, so that'll work. Okay.
그 로켓 안에 있어?
그 플라스틱 통 안에 있어.
아, 플라스틱 통.
Yeah. So the one we requested, it was triple F, and we'll request the one with the 4F. Do you think that will be better?
Now, the other option is Animal Motor Works will have their trailer on site. And when you're talking to them about the motor, having the motor built and that kind of stuff, you're picking up your motor from them, you can mention to them, hey, do you guys have any 4F? Because they're supposedly going to have 4F as well.
Oh, okay.
Now, if they try to sell you a 1 pound can, which is a huge, 16 ounces,
yeah,
you guys won't need that. I mean, you'll need like an ounce if the most to cover your full rocket and testing and all that kind of stuff. So I give the same warning to all the teams. If you have to, that's great. But see if you can sell it to the rest, all the leftover, sell it to a US team. You know, it was like, you know, we bought it for like $25. You know, freaking here, we'll give it to you for 10. Just, you don't want to carry that 1 pound can around, because that's like 4 sticks of dynamite.
Okay.
So yeah, you wanna put it into like a little small container, and just take what you need out of that can, and then keep that can somewhere safe. And it's hard not to do it in a hotel room, but you know, it's, again, worst case scenario, if something were to happen, a 1 pound can of black powder would completely destroy a hotel room
Oh,
if it were to have an incident. So that's
but
why I've got 2 1 pound cans in my garage in safety boxes. So if they go off, the box will be destroyed, but hopefully the garage will survive. When I go out to a rocket launch, I have a small little Tupperware, a little plastic container that, I mean, is literally like this, and it only holds maybe 15 grams of black powder. Because you know, if that were to go off, I'd get burned a little bit, but it wouldn't
yeah,
kill me. So, anyways, keep it as small containers as you can. Um, if you can make the charges and seal them up before, that's great. That way you don't have to carry any of the black powder around. You just carry the charges with you. But
yeah.
certainly test the black powder, because we have run into situations where an entire can of black powder somehow made it from the manufacturer, and the black powder was bad. And
Oh,
so they launched a rocket without testing it, and the black powder didn't go off. And, you know, obviously had a very fast descent.
a very fast disassembly.
Oh yeah, it wasn't pretty. It
Oh
was
yeah.
they call it a shovel recovery, where you use the shovel to dig the rocket out of the ground.
Oh my gosh. Yeah. Okay. Quick question. Is the one with the triple F acceptable for the rocket recovery? Because I think the one closer to the black powder we made is the triple F. So can we
Oh
use?
yeah, yeah, absolutely. A lot of teams, Canadian teams and other teams, use they call it. I mean, that's considered pyrogen or smokeless powder,
Okay.
and it just it absolutely will work, but you've got to compress it very well. So
Yeah.
that in your container, usually a small little round cylinder or something, you have the E match in the bottom of it that ignites it. You put the pyrogen on top of that E match, and then you use something to fill in the gap. And so the gap, I guess we use something called dog barf, which is a attic insulation. It's a it's paper. It's a cellulose based fireproof type material that you just pack down into, and you fill up that container with the remaining, and you compress it as best you can, and then cover over the top of it with really strong tape.
Oh,
And that is your ejection charge. And there's nothing you can do. You can shake that charge all you want, and that black powder will stay down in the bottom near
yeah.
near your E match.
Okay. Thanks for the advice. So
Yep.
this is the actual black powder charge that we made.
Okay.
It's sealed with a thin layer of plastic, and the image we use is the one for the fireworks. So we tested this thing like over like 50 times, and it works great. So we'll
Yep.
make a similar one at the site and test it at the test site you have mentioned. So thanks.
Okay. So that's great. Can you hold that up fairly close to the camera? I just wanted to see it real
Yeah.
quick.
So this is the powder.
Perfect. Yeah, absolutely, guys. That looks fabulous. I'm a huge fan of hot glue. And so we use I do that on mine, and they look like little laboratory specimen container kind of things. And, you know, you can fill them up, and then you fill in the gap and such. But I will hot glue that E match right into the base, and then, you know, just make sure it's relatively in the middle, and then make sure it's well compressed with no air
Okay.
in there at all, and then just protect them. You know, wherever you go, you know, just make sure that they don't get left in the dash of your car while you're out in the desert.
Oh,
Kind of
okay.
stuff. So
The car
yeah,
will
don't forget about them.
Okay, we'll
That looks good though. That's I like those. Those are good designs.
Oh, thanks. Yeah, we were worried about putting the hot glue at the close to pyrogen, but yeah, I think it's rather safe. So yeah, thanks.
Well, I mean, you would do the E-match. Oh, that's right, because you do that at the end. Yikes.
No. We do it at the first and then put the pyrogen.
Oh, okay. I got you. And then seal the other side. Okay.
Yeah.
Yeah.
Yeah, it will be a crazy thing to put the hot glue gun at the pyrogen. So.
Yep.
No, well, we didn't know about the compression thing, so we'll make sure that we'll do enough compression to the charges. So thanks for your advice.
Yep.
Okay, and this is the result of our ground test, and the main reason of the failure was the circuit and the failed sealing. And the fifth one, we used a different batch of black powder, and it was very defective. So yeah, we'll
Yep.
go with the normal one. So, and the dynamic test, we were worried about the recovery's reliability at the apogee because there will be like 20 meters per second of the wind coming at the front of the rocket. So we made a test device that could anchor the rocket at the top of the car. And this test device includes a rotation wheel. So the rocket actually can rotate after the parachute is deployed. So the results was very good. So we'll show you the video. Yeah, and the speed was like 80 kilometers per hour. What's that in miles?
Yeah, that's significant. That's,
50
okay.
miles per hour.
Yeah, it's okay. So this is the full video. Yeah, we accelerate. I think. You have to keep it front. And this is when the payload should deploy. The payload was deployed separated from the rocket, and this yellow thing is the rocket. It still has a temperature sensor to connect it to the rocket. And yeah, it separated and it deployed the main chute. And the main chute was tangled with the test structure, but I think it won't be a problem at the actual flight. So that was
Okay. That's awesome.
Thanks.
Holy cow. There's a whole nother podium session right there, just building up that testing system. That you guys have got to send me that video. That
Oh.
is awesome.
Thanks.
Yeah, I remember you guys mentioning how you were going to set it up, but actually seeing it is it's different, and I do appreciate it. So congrats.
Yeah,
Thanks.
that is really cool.
We'll actually try it some more time before the competition. So we'll make more videos of it. And I think this is a very good method of testing because other rocket teams too don't have many launch opportunities, but we can still test the recovery system by this car device. So I think it's a good thing for other rocket teams too. Okay, and can you hear me? I think the internet.
Yep.
Oh yeah, thanks.
No, you're good. I'm sorry. I was being distracted by another team.
Oh yeah, not. Yeah, okay.
Yep.
And the final slide is the improvement plans, and we actually tried to review other rocket team safety review, and the concerns that the mentors made was pretty much same to our ones too. So we are trying to reinforce the middle part of the shock cords, which will be interacting with the edge of the fuselage, and
Yes.
yeah, you will reinforce that with duct tapes if that's okay.
That's absolutely what I do. Absolutely.
Okay. So great, thanks. And Some parts of the shot cords that we were going to show you, they're not the ones with the shot cords we have shown at the previous slides, but we'll replace every shot cord to the thick one that you mentioned. And we were also worried about the tangling of the shot cords. So maybe we can use some the methods at the figure below by rubber bands or masking tapes to ensure the tangling doesn't happen at the inside of the rocket.
Definitely could do that. So kind of talking about your parachutes and whatnot, what are you guys actually using to protect them? So deployment bags or recovery wadding or a parachute blanket? What
Well,
are you guys using?
well, the first method was to separate the place where the parachute is in and the other electric lines and other lines are at. And for the inevitable shock cords, which has to be with the parachute, we use some kind of what do you call for now? Help me 따다닥 해가지고 이렇게.
Zip tie?
Zip tie, yeah, zip tie. I couldn't figure out that word. And yeah,
So, for at least that main one, my recommendation would to be, you know, how you guys were, it came out tangled, and that will happen in flight a lot too.
Okay.
And your rubber bands or how this diagram is presenting them. A parachute bag would kind of do that single loop method. It would actually you fold and properly pack your parachute and would protect it from any of the explosive, you know, charges, but it also would help those shroud lines and the shock cord actually stay very much compact and tight. And it actually might help you guys with that tangling that you saw. So I would honestly recommend that,
The
maybe to
single,
help that. It would so that parachute bag, when you do the shroud lines and the shock cord lines, it has basically a part of it where you actually web or feed through all of the lines so it keeps them in line if you do it correctly. It does essentially do like this loop method, and it
okay,
keeps it very much compact and tight. The way, if you follow the instructions and videos properly, it does do the same method, and it would possibly help you guys so you wouldn't be tangled like you saw in the video.
okay. We'll try to work with the loop that you have mentioned. Thanks.
Real quick question: who is your flyer of record and I guess mentor that you've been mentioning before?
Oh, it's Mr. Pierre Ramalho.
Pierre Lar.
He's in this
He's on
Zoom.
the call.
Yeah.
Wait, Peter Tarl?
Peter Loranjo.
Lorenzo.
Oh, sorry.
Sorry for mispronouncing Mr. Loranjo.
Okay. So it's not sure I've met him yet. All right, but he's a triple E level 3 guy.
Okay. Yeah.
Yes.
He is.
He is okay, and he's going to be at the cup with you guys for the launch.
Yes, that's
sure.
correct.
Okay. Very good. Has he been working pretty closely with you throughout your design?
Actually, we didn't make much contact because the development phase has had much problem.
Yeah, but his opinion was critical in changing our recovery system design.
Yeah.
Okay. All right, just make sure you keep him in the loop. And the reason I say that is same speech I'll give everybody else's. During the flight, Spaceport America requires us, the competition, to have insurance for the student teams. And to get insurance for the student teams, to force the student teams to do it yourself, would be thousands and thousands of dollars per team, and it would create a nightmare. So we have implemented a process working with Triple E Rocketry Association. That's why Triple E membership is required. It's strictly for the insurance.
Oh.
But to launch a rocket of that size, you must have a appropriately certified rocketeer who puts his or her name on that flight card. So Anita's L3 qualified. I'm L3 qualified. All of the range safety inspectors are L3 qualified, meaning we've built rockets this size and launched them before.
Yeah.
So we have significant experience in it. The challenge that we run into, and the reason why this is still a sort of odd situation, is you guys are building the rocket, but the person that is officially flying it is your flyer of record. So
Yeah.
let's say, for instance, a horrible situation occurs and the rocket parachute doesn't do what it's supposed to do, and the rocket, unfortunately impales somebody's car.
Oh, yeah.
And obviously insurance and all that other kind of stuff. In the real world type scenario, you guys would be responsible for it. You need to come up with the money to pay the repairs and but the worst case scenario is you injure someone, that your rocket falls and actually hits somebody, or your payload hits somebody, or whatever. And that person, is severely injured or worse, dies. Now we've got courts that'll get involved. The police will be involved, and there could be multi-million-dollar settlements. You guys don't have that kind of cash, and that's where the insurance has to be in place. And so the problem we run into is the flyer of record is the person that's responsible for any event that occurs with that rocket. So this person needs to understand they're taking on risk by putting their name as your flyer of record. So we want to make sure that they understand how safe the rocket is, and there's very little chance of any type of incident. But if there is, the way we're doing it is Tripoli Rocketry Association will cover the flyer of record for anything that potentially could happen. But we need to make sure that that flyer of record is actively involved in your design, and that they're completely comfortable launching it. If they have any hesitations, like they mentioned before, I would be concerned with mechanical spring-loaded ejection systems. So I've seen them time and time again. In fact, I've never seen one actually work appropriately. So he can step back and say, I'm not putting my name on that flight card. That's too dangerous. And at that point, you guys aren't flying. It doesn't matter if we sign off as safe or not. If you don't have a flyer record, you're not flying. So you want to make sure you keep him very much in the loop so that he's completely comfortable being that flyer of record. And if he makes a recommendation and you guys are arguing with him over that, understand he can step back at any point in time. It's like, I'm done. I won't sign off on that. And then he won't. And we either try to find you a new flyer of record, or you, I guess, make the change that he requested, which would be my recommendation.
Yeah.
Okay, that's it. That was my speech.
Yeah, thank you for giving us the understanding of the issues regarding the insurance. And
Yep.
we actually had some hard time getting the L3 mentor, because as an international team, there wasn't a US citizen nearby. And thanks to Mr. Alejandro, he's also the mentor for the Oronos team, that he will be our mentor too. So we'll make sure that we'll contact him more frequently and in the design process. Okay, thanks.
Fantastic. That sounds great, guys.
Okay, that's end of the recovery part of the presentation. So I'll get Peter back. So thank you for listening. And thanks.
Oh. That's a long explanation regarding our recovery system. Okay, so thank you for listening, and we'll go for, well, although you did ask us questions in the middle of our presentation, are there any more questions that you need to us? You're going to ask to us?
Oh yes, lots.
Lots.
All right, so let me throw out real quick. This is where we need to turn off the presentation, and we need to have a camera on the rocket so that we can go basically a top to bottom ability to see the rocket. We want to see it, how well in the build process or how complete it is.
Okay.
So
let me change the camera then.
Maybe we'll do it at the outside.
Okay. Since our room is a little bit small. Can you give us a minute to?
Absolutely, guys.
Oh, and before we see the rocket, can I ask you? Oh no, I'll ask you when we show you the rocket.
Okay.
So let me change the camera to my phone. Can you see screen?
Yeah, it's ready, and I think we should see. We should make them see our rocket team room. It's very small. And maybe they also
This is our entire rocket room.
It's very small.
It's
and
very small.
You have a hard time building rockets.
It's quite squalid.
Guys, if y'all think that's small, I can show you small. We've seen broom closets.
Okay.
Yeah, but you're good.
But never stop asking for more space, because I've also seen, it was the Youngstown State who is getting a makerspace put together, and they are getting, I forgot how many square feet. It's like 1,100 square feet for their rocketry area.
Sorry, but let me change our. Pardon me. The Wi-Fi isn't good in the aisle.
The other room, yeah.
I think we have to go back to our room because the Wi-Fi isn't good outside. Apologies for the delay time.
No worries.
Okay.
So let's look at the rear end of the rocket where you would put the motor case into it. All right. Now we see, let's see, go ahead and there we go. Now you guys are not using an actual motor tube. You're just having the case go directly into the centering rings. Is that correct?
That is correct.
Okay. That is not really nominal. That is a very probably bad situation. Here's the scenario. The centering rings that you guys have. So right now, what I'm looking at in there, you'll just slide the motor case into that. Is that correct?
We're going to detach this part, slide the motor in, and then attach this most aft ring. So it'll be secured between the bulkhead at the very front and this rear centering ring.
Okay, so let me stop you real quick because we're going to have a little bit of a challenge here. When that motor, the reason that we have a motor tube and centering rings is a transference of the motor thrust to the body. So I was excited to see in your design that you had the 4 centering rings. Each one of those centering rings, when it's attached to a motor tube, and the motor tube is the part that the motor case, the metal case would go into the motor tube, and the thrust of the motor pushes that motor tube forward, but all of those centering rings are epoxied to that motor tube. And so all 4 of those are anchor points for it. So what you're showing me in this design is when that motor goes in, the only thing that's stopping that motor tube from flying right through the top of the rocket is that last centering ring at the very top.
Yes, that is correct. So that is
Okay.
why we load tested the bulkhead that's at the very front.
And that withstanded
That withstanded 4 times the maximum thrust that the motor specifications showed.
so the bulkhead itself getting that thrust is, well, we worried about that too. So testing the load test is not acceptable.
Yeah, again, you've got one point of failure with that forward piece. That's I don't know. I need to jump in here. Help me.
Yeah, I'm also very worried. I see you guys epoxy that top one in, and that aft one's gonna come out. But did you guys actually epoxy, I guess, the other 2 centering rings in there as well, or are they just held on with the rod too?
They're just held on the rod. We didn't epoxy them to the body tube.
Bulkhead.
Okay, so you have even more failure if that rod just lets go completely. I mean, you have 3 of them, but there's a lot going in there that motor tube would have transferred, and even epoxying your centering rings to the actual tube would give probably even more strength. But they're almost like independent, not together. Usually when you build the fin can, they are, essentially individual pieces, and then you start building them together to make one solid rigid body. Here they're not even really rigid together, except the only thing that's really rigid is that upper centering ring right now. I would not be comfortable with this at all.
Mhm.
So if we epoxy the centering rings to the
Centering rings, I
Center-
mean, that would help drastically, but you don't have a motor, like the casing, of course, is there, but usually, like Andy said, we have a motor tube that goes in there and everything's tied to that, and that inner tube and your exterior tube. So you would have to do, usually we have internal fillets and exterior fillets to that outer, bigger tube and the inner tube. So I don't really know how we can go as far backwards, but yes, probably epoxying all of those rings in would be a better idea as well. That'd be a start, but I don't know how to go from right here at the moment without a tube.
The centering rings. So we see the outer centering ring looks like fiberglass. That's great. What are the inner centering rings made out of? Are those some kind of plywood?
Yes, it is plywood.
Okay.
So they still can come out essentially. Could you guys I mean, they're plywood. Could you sandwich them too with fiberglass and then epoxy it in place?
So
Wait, can all of this come out?
Everything except the top. That's what I'm understanding. Please correct me if that is wrong.
Do you need us to pull this out?
Yeah, can you pull that out?
Yeah. Just please wait for a minute.
Can I talk for a minute here?
Yes, this is Zhu Yang, our aerostructure team leader.
You can just call me Gwyn anyway. So first of all, yeah, well, the main concern for us with applying epoxy to attach the centering rings to the fuselage is that it's kind of, first of all, it would be irreversible, and second of all, so our concern was that it would be kind of difficult to assemble it, since there is really if there's not much, there aren't that many ways to glue all of the 4 into place, because you're sliding, the only way that we could think of is to apply the glue around the rim beforehand and then just pushing it into the fuselage so that the glue somehow just slides in or something. So what would be some other alternatives in assembling this with more structural integrity?
Sure,
yeah,
sure.
like
No, I
other ways
understand
to
exactly
glue
what you're
them
saying.
in.
Yeah, that is definitely a challenge that all folks that have built rockets this size run into. And so one of the solutions I've run into is you have the ability to epoxy in the front centering ring, and you have the ability to epoxy in the rear centering ring, the thrust plate. But trying to get any epoxy in between that area has always been a challenge. And so I've resolved that in the past by just finding a nice little spot in between, say, the second or the second and the third centering ring, drill a small hole in there, and put in some basically you get like a syringe full of say 4 or 5 ounces or more, depending on how big it is, of laminating epoxy, the very viscous fluidic epoxy, and in that hole you would just squirt it in, and then you start rotating the rocket body at an angle so that the epoxy goes down and meets that edge of the centering ring, and you just keep rotating it until the epoxy sets up. And then when you're done with that side, you use that same hole, do another 4 ounces, and do the same thing on the other, and that'll create fillets on both the sections. Now you got a hole in the rocket, and so what you'll do when both of those front and rear of that one section is set up, you would put in another maybe ½ ounce or so, and then put tape over the hole, flip the rocket upside down, so that the epoxy sets right in that hole, right where that hole was. When you pull the tape off, the hole disappears. You sand it, paint it, whatever you need to. And then you do the next
ingenious.
section the same way.
Just think about that.
Okay, so all right, so let's look back in the body tube real quick and see what we can do with all these centering rings. Let me see what the front centering ring looks like. So put the camera down in basically into the tube again, and let's look down inside what it's looking like. Okay, so that one is already in there. You've got the threaded rods.
Yes.
Okay, so that looks like it has a good setup. That looks pretty well configured. All right, let's go back to the rear end, the back end section where we were a second ago. So at this point, you do not have the fins coming through the body, and that's okay. But I would highly recommend, and I don't know how quickly you can do this or not, but if you can find a 98 millimeter tube, a body tube that's 98 millimeters, that your motor case will go into that 98 millimeter. With that 4-inch 98 millimeter tube, bond those centering rings to that tube, and then insert that, I guess the 2 centering rings and the other one, and then insert it into there, and then epoxy all the pieces in place, all those centering rings in place. And that way, what will happen is the rear of that tube, your motor case will slide all the way up to it, but there is a section to the motor case. Do you have your motor case by chance?
It was lost. It was stolen. Shipping it to Korea, so we had to buy another one, and because of the shipping time, we resulted in getting it on site.
We have the one for the flight model, and we wanted to get the other rocket motor tube to Korea, but it was stolen at the process. So we only have access at the site.
Yikes. I hate to force you guys to have to re-engineer all of this, but that is going to be, you can't have, and it doesn't matter how much testing you did. I don't think any of the range safety guys are going to authorize a single point of failure, meaning that forward centering ring, to be your thrust plate. The thrust plate should be anchored in a centering in with multiple centering rings, and should be inside of a motor tube in the rear of the rocket.
So if we do the process that you've talked about at when we go to US and epoxy the centering ring to the motor tube and the rocket fuselage, is that okay?
Yeah, if you
would
can,
re-
again,
yeah,
the thrust of that rocket will be transferred to the tube, the motor tube. And then the motor tube is anchored to the body tube of the rocket at the centering ring. So each centering ring will deliver the thrust force to the body of the rocket. So if you would essentially have to lose the rear thrust plate, the center, the second and third centering rings, and the forward, all you'd have to lose all of those for your motor case to essentially fly through the rocket. Whereas right now, if you lose that front one, then you've lost that motor. That motor will just fly right through the motor case, and you'll have a lot of excitement on your hands.
Okay.
Thank you.
So off of Andy's point, I think you guys are in a spot where you still could also, so buying the casing, that's going to be on site, but getting that 98 motor tube, so it's a fiberglass tube essentially, usually, that could possibly ship to you guys really quickly. You would epoxy your center rings outside, and you're in a position where you could not just rely on that top center ring as your thrust plate, but you could get a aft retaining ring, and that would be your second part. You would epoxy it in as well when you're doing that that tube. So you're in a spot where you still can do that, and that would give confidence at range safety inspection as well. So you're not just relying on that top section plus, the other center rings. You're going to have one at the top and you're going to have one at the end. That's what I would recommend as well.
Okay.
The provider of the body tubes is local. Is that correct?
Yes, that is correct.
But
Maybe
you
they
don't have
have
a motor,
motor tubes.
right? Does he have a 4-inch piece of tubing that you guys can use?
No, we don't. We hardly found this dimension.
그러니까 100짜리면 98이어야 돼. 98이라는 수치가 한국은 살 수 없다고.
Yes, the 98 diameter. it's hard to find here in Korea.
Sorry, guys. All right. Well, I'm just trying to come up with some options that might be able to get you going a little faster, so you don't have to wait. I guess another question. When do you plan on arriving in the U.S.? On what date?
About June 17th, and
On Thursday. 15.
between June 15 to 17.
Okay, so you're talking like Thursday, Friday before the event?
Yes, Thursday, Friday, Saturday.
That's great. That actually gives you time to potentially do this.
Yeah, it does.
So get the motor tube at the site and do the epoxy applying thing that you recommended. Is that okay?
Yeah, I think so. But you're going to need some guidance and some, to ensure that. And again, that's where your mentor can maybe step into this as well, and maybe Anita and myself. I'll be getting there on Friday beforehand as well. So
Maybe
you know,
Thursday. When is your mentor going to be there? Or your flyer of record going to be there? Is it going to be there with you guys or a little bit later? Do you know yet?
As far as I know, we did manage to stay at the same motel.
With
Where are you guys staying?
Motel 6 in Las Cruces.
with the
Okay.
Canadian owners team, with maybe with a mentor.
Yes.
I think we're gonna have to link up to really get you guys because the vendor doesn't get there till basically the day it starts or maybe the night before it starts. So we're gonna have to figure out how to get you guys a 98 just motor like tube. That would be the key piece here. And it delivered to basically Las Cruces. Because you guys got your centering rings. So that's a great start. So we're gonna have to work this out because it is
yeah,
gonna take some
we would need
time.
we need to sand out because
Yeah.
the centering rings will need to be a little bit bigger to handle the outer diameter of the 98 millimeter tube.
Okay, making another centering ring will be rather easy for us. Yeah, that won't be a
I was
problem.
like, if could you guys actually model like so I know they have notches cut out in them. I mean and even the rods, I mean, we theoretically could keep the rod idea going too if you wanted to, or we could completely, take that out. But essentially if you guys could remachine them or re-laser them and account for that outer 98 millimeter, we would already be that much better. Instead of us having to sand them and Dremel them and fit them to the actual new tube,
Yeah,
if that makes sense.
we have access to a laser cutter, so
Okay.
I think it'll be better for us to make new centering rings.
Okay. That's a huge step there. So okay.
I have another question. Is the plywood centering ring acceptable, or do we have to reinforce it with FR4 plates?
How thick are those centerings? Like, can you hold one up? Or like one of the middle ones, the plywood ones? I've seen them before. So,
That's
Oh
like,
yeah,
I believe that's like a fifth of an inch, 5 millimeters.
yeah. If there are 4 of them, that should work. I shouldn't have
yeah,
any
it
problem
should
with that.
work. Yeah, there's no problem with that. So, I would say machine just a few more just in case we need to. But okay, so Friday night.
Oh, Mr. Lorndo has.
Yeah. Yeah, he said when he was gonna be there.
Cool,
Okay.
that's great.
But yeah,
Thank you, Pierre.
okay. It's doable. So just cut out some of them and bring them with you guys.
Okay.
Okay.
Another quick
Bring extra just in case because
Yes.
we have lost a few in processes before. So
Okay.
extra is a little bit better.
Okay, we'll bring extra parts. Thanks.
Yeah, like 1 or 2 would be great. So we can do that. Andy, am I allowed to help them get a motor like tube delivered? I think it's gonna be a little bit harder for them.
Well, you guys have already ordered one, correct? Through like Animal
Well,
Motor
like
Works?
that's the casing. So they got the casing, but we're talking
Right.
about like a fiberglass tube or a motor tube, like in that case, not like the actual 98 with Animal Motor Works. Like they'll get that with them on the site, but to do their centering attachment point, we're
Oh,
gonna
I see. I see. To have it actually
yeah,
delivered to Korea?
yeah. Well,
I
not to
got you.
Korea. We're gonna probably have to do it in Cruces,
Okay,
realistically.
I got you.
I could have it delivered, and we'll have it waiting with them, and I don't mind helping them actually do this.
If you're comfortable doing that, fabulous.
Yeah,
Really
I
great.
love this part. So,
No,
I don't mind helping you guys. So, a little fun fact, I was on the New Mexico State rocket team for 6 years.
Oh, really?
So this is the back end propulsions are what I love to do the most. So I do not have any, I will be there early. We will work this out so you guys can pass the safety check for this issue because this is something that does need to be addressed.
Yep. So let me explain real quick, just I guess a differentiation between judges and range safety inspectors. So Anita and I are part of the range safety launch operations team. We do not score anything. So we wouldn't come out and say, okay, your rocket is about, I would say 85. You're going to get a B plus on your rocket. And that score would eventually lead to, your performance and overall that you would get an award for this being third place in this group or whatever. We don't do any of that. Our single role, our single thing is thumbs up, you can fly, thumbs down, you cannot fly. That's all we do. And so our goal is to try to make sure we get the teams every chance possible to get their rocket ready and passing that safety review. But we will not score. There's a whole separate team that will be looking at the scoring and how well you built the rocket and the overall performance of the rocket during the launch, et cetera, et cetera. And then all of those people, again, completely separate from us, they will determine how well you do in the overall competition. That is not our role. All we do is you get to fly or you don't get to fly. So I'm totally comfortable. That's not considered out of the norm for, if you're interested in assisting them to get them going, Anita, that should not be a problem.
Okay. If you guys would like that, I am willing to help you guys out. I will be there Thursday morning, so
Yeah, that
we
would
can
be
do
a
this
great.
whenever.
We really
Okay.
appreciate your help.
Yeah, that would be a tremendous. Thanks.
Of course. Like I said, just get those centerings, bring them with you guys, and we'll work the rest out, at least with this section.
Yep.
When you guys get there.
Okay.
Okay. So since we're here, you know, we already identified that, but let's flex your fins. So during so take 2 of them and actually the fin flutter. So try to pull, like, hold that tube, but you're gonna take 2 fins and you're gonna try to push them together. So yeah, and then grab the other one, and then pull them together, push them, pull them, basically. So they wobble.
We
That's
actually
like,
smashing with a hammer before.
Yeah.
okay, so you've
Well,
already
well, not
basically
twins.
done this massive test before. Okay, that's what we want
Like
to
not
hear.
with
So
these ones, obviously.
yeah.
So when we actually we smashed it or like on we use like samples with like tiny like little pieces of the same material and then like a
So
tiny test tube. So the FRP, the GFRP layers, the wet layup finish on the top was the first to get out, and then the rest was still sound. So yeah.
So the test sample is always perfect, but that test specifically that we just had you guys do really tests how they're mounted onto that tube in that section. So traditionally there's 2 ways. I usually just do through the wall. So you guys, that's why we were asking when you slid everything out. Usually you actually can cut slots in and have your fin actually go inside touching your centering ring. So that's a through the wall mounting. You guys are actually right on the like the outer edge mounting, so it's not through the wall. So that attachment point is very critical. So even though you guys did that sample test, actually how it's mounted on there is only going to be identified when we flex it like we just did. So I'm okay with that. Andy, what did you think about that?
Yeah,
That test that they just did.
what happens with fins, particularly when they get near transonic, is vibrations. I mean, vibrations and adjustments are occurring, 1,000 hertz, per second. So the fins, even though you may not even be able to perceive it as they're flying through high speed air, they are vibrating. The key piece is the farther away from the body tube, the more the vibration. And as you proceed through transonic, that vibration, if that reaches all the way down to the actual body tube itself, you'll notice the fillets will start creating cracks. And eventually, through either aero heating or through the vibration functions, the cracks weaken that fillet, and eventually they will come completely loose and separate from the rocket. And you will see that happen out there. We call them shreds. We call them a lot of different things, but basically the rocket the motor outperformed the body tube. And so when one of those fins eventually rips off, the rocket will shear in half because no longer does it have 3-dimensional stability. And so it'll try to do an airplane on you. And as it's going up, the rocket will basically try to go horizontal. And when it does that, the forces are so extreme at such high speeds that you'll watch the rocket actually fold in half. And so we watch that. You'll see multiple exciting times when that occurs. So let's say between the right side fin that I'm looking at and the left side fin right now, you have the surface mount, meaning you bonded the fin to the surface. The fillets are typical, the excess epoxy that you would create a bead between the fin and the body tube. So I can see that you've got some fillets there, so that looks pretty good. How many individual layers of fiberglass cloth went between fin number 1 on the left and fin number 2 on the right?
4 layers.
I think
Beautiful. 4 is fabulous because I see one of them. I know there's at least 2, but I wanted to double check that. 4 should be more than sufficient. And again, if you guys were going Mach 2.3 and you were going to be above Mach for 3 seconds, I'd be really worried about this. But this looks really good. I don't have any concerns with that. With 4 layers of tip to tip, that should be nice and solid.
You mentioned the little cracks on the what do you call them? Like on the fillet developing into like a fracture. So like, would you recommend some kind of like a fatigue test or something on the fin attachment, or would that be excessive?
Probably a little excessive. Again, if you guys are doing high Mach numbers, we might want to take a look at that. But this is not only is sufficient for not even breaking Mach. What is your max velocity? 800? 800 feet per second?
It's not 1.95. 1.95.
It's Mach 1.95.
Okay.
0.95.
Sorry about
yeah.
that. 0.95.
Yeah.
1.05.
Okay, that's fine. It's close, but again, you won't be in that transonic region very long at all. So again, I think the fins are definitely sufficient. Let's talk about the actual recovery points, the where your shock cords are going to attach to this section of the body tube.
So this is the recovery part.
Okay,
And
nope. Guys, I'm still on the fin can. How does the shock cord attach to the fin can?
How does the shock cord attach the what again?
Oh, I'm sorry. That doesn't actually eject, does it? Everything comes out of the front.
Yeah.
So okay, how does it mount? How does the rocket, the base of this section I'm looking at right now, how does that mount inside the fin can?
We're using a coupler.
Okay.
So you can see this tube.
It's also pre-preg, the same material, and then we also had to reinforce the insides with several more layers of fiberglass.
Okay. And so you'll just slide the upper half of the rocket onto that, and then
No.
This does not separate, correct? I mean, during flight, the upper section doesn't separate from the bottom section. Is that correct?
It does not separate.
Yep.
That's correct.
That is correct.
Okay. So how do you bond those together? How do you ensure that during flight they don't accidentally separate?
위쪽에는 볼트고 아래쪽에는 어디 있어?
For the bottom part, we're going to use structural epoxy, and for the upper part, we're going to bolt it down.
Okay, so we need to talk about the bolts then.
We're not applying the bolts directly into the fiberglass. We're just gonna punch holes on them, and then of course, there's the to prevent any additional shear stress on the layers. We are using indirect methods in bolting them together.
Okay, I'm still gonna need to know what those are. So if we got 4 bolts that are going through and cutting, putting small holes through that's fine. I mean, I need to know, is it 4 bolts, 6 bolts, what type of bolts those are, and how you're anchoring the bolts on the inside, those type of questions.
And 5 4개지.
So
So we're basically using 4 and 5 bolts, and actually we are using this. Could you see this?
Yep, absolutely. That looks great.
This is a small block of wood, and another is inserted inside, and this will be structured. This will be attached into the coupler.
Yep.
With the adhesive, with the structural epoxy, and we will just drill the coupler, and M5 will be attached.
Okay, I like that. That sounds good. Are you good with that, Anita?
pardon?
Yeah, well, I'm good.
Okay. All right, that's good. We like that. Okay, let's swing over to the other half of the rocket.
So this is acrylic. We put this in acrylic just for demonstration purposes. For the real rocket, it's gonna be the same body tube, just right. It's gonna be inside the body tube right here.
Okay, make sure that I'm just throwing this out for display purposes. On Tuesday at the convention center, it's all about show and tell. So you're going to be talking to judges, scoring judges, all day long at your table. It's like going to a convention, and so having a clear acrylic tube to show people what's going on inside the rocket. If you guys can do that, that's great. Again, if everything needs to be epoxied beforehand, that's understandable. But judges love to see what looks like inside the rocket. They really do. So that's always fun. But if you guys can't do that for for the final rocket, that kind of stuff, that's understandable too.
Thank you.
All right. So the nose cone itself, do you have any functions like a shear pin or anything that that will keep the nose cone from I guess what will happen is as the rocket accelerates and ascends, pressure, vacuum and differentiation and pressure, every once in a while can pop the nose cone off mid-flight, even without an ejection charge. So the teams will often use some type of shear pin function to ensure the nose cone stays in place. And then your ejection charge should be strong enough to basically crack or break those shear pins. Do you guys have any of those on your nose cone?
No, we do not.
Well, the shoulder is 1 caliber deep, but we don't have any shear pins applied to the nose cone.
Okay, so there's often a test that you can utilize to determine how many shear pins or what shear pins. And if you grab that nose cone with the rocket underneath it, and you lift the nose cone up right at the nose cone, if it's in there really tight, it should lift the whole rocket up. But if the rocket starts to slide off of it, that's guaranteed that you need to have some type of shear pin in there. And even at this size, I would go ahead and state that to find these are nylon like 440 nuts. They're just plastic nuts, and you would drill 2 or 3 holes into the body tube, and you just press these nylon nuts into the body tube and through the nose cone, and that will keep the nose cone from accidentally coming off. And when the ejection charge fires, it just shears that nut. All 3 of those nuts, or 2, whichever one you want to use, it just shears them off, and still allows you enough force to eject all the pieces parts. So that's typically something that the judges will want to see as well.
Oh, okay. So if
We will consider it.
if I pull the nose cone out, I'm sure that the rocket will slide down, so that would be unacceptable, right?
Correct.
Okay, so maybe
Especially if it's just the upper section. I mean, it should be able to hold the weight of the entire rocket. And that's why the shear pins are probably highly recommended.
okay, we'll apply the shear pins to able to lift up the entire rocket. Maybe
Okay.
up here or at the shoulder part.
Yep. Yeah. I mean, basically right where the nose cone separates from the body tube.
Okay, we'll apply a new shear pin to it. Thanks.
Okay. So let's go ahead and separate it as if you just fired off your apogee charge. Show me where it would separate.
Okay, maybe we'll put this horizontally at the chair. So let's put it this way. Okay. So like the schematics we shown you before, the charges will fire and pull and eject the nose cone out of the fuselage. And
Okay.
the pyrogen deck is tightly sealed inside the nose cone. So now the pyrogen deck came off, but in real flight, the pyrogen inside the nose cone will fire. So this won't come up like this. And let me just pull out the pyrogen deck. Yeah. Oh, yeah. So this is what's gonna happen, and the nose cone will eject and pull out the deployment bag like this. So the payload parachute will deploy, and this is the. Can you show the inside of this part? And the center part is going to be the place where the parachute is going to be on, and the rest of the part is where the pyrogenic charges are on. So there are two charges will be placed inside, the main one and the redundant one, and only one charges is enough to eject the entire nose cone. So this is the first step, and do you have any concerns here?
All right, so the nose cone will push this towards the rocket body. And
The pyrogen inside this deck will push out the nose cone from the body.
okay,
The reaction
it's
will.
interesting. I've never seen a little barrier like that. That's pretty neat. Nita, how do you think physics wise that's going to work?
No, okay.
No, please continue. Sorry, but physics wise, I mean, I'm a little concerned, honestly, on this whole thing. But I mean, that's printed, it's 3D printed, and then that hole honestly might have to be a little bit bigger too, with all the new shock cords that you guys are gonna have to get in there.
Okay.
Yeah, because those shock cords will be much larger.
Yeah, they're gonna be much larger.
Okay, thanks for
Mm,
the opinion.
Yeah.
This part is printed in PLA, but the actual part will be printed in
The PACF.
yeah. We have the one printed here. Yeah.
Let's look at that because
The one
so the
print-
hole's definitely gonna have to be bigger. But so
Yeah,
okay, that's definitely a lot stronger.
yeah, we will enlarge
yeah.
the hole for the
It's
output. Yes.
Mhm.
And this is much stronger than the white PLA one.
Okay.
And the next step, the payload parachute will pull out, and before the payload comes out of the this section payload bay, the tender descender here will stop it from pulling out entirely. And I think there will be another shock cord applied to this carabiner and the payload eye bolt, so it won't come out of the payload bay at all. Yeah, and this is the custom made tender descender I've talked about before, and this would be, I think we will change this to a COTS one, so that won't be a problem.
Okay.
And
All right. I wanted to look at the anchoring points. All right. So the camera, yeah, right there. So, wow, that's going to be a little hard to get to. All right.
Yeah.
So that carabiner is going to need to be replaced.
Yes.
And obviously that's a piece of nylon jump cord that's probably going to get replaced, right?
Yeah, we'll replace that with a more proper Kevlar one.
Okay. Okay. I think the eye bolt, again, you guys keep mentioning 200 pounds. I'm fairly certain that eye bolt will handle a lot more than 200 pounds.
Maybe there was some confusion while I was changing the numbers to pounds, and yeah, I think this is rated enough, but we will find a new one for the main eye bolt at the bulkhead.
Okay, so that's on this side. Let's go look inside the other anchor point inside the nose cone.
Okay. Well, this nose cone is for test purposes, so it's 3D printed in 3 parts, but at reality, we have one with the wet preg one. Maybe we will show them.
It's
This is the one we manufactured. It's
Okay.
same shape. So in here, the shock cord is put with duct tape inside the nose cone, but that will change at the actual flight model. The small deck, which is used structural adhesive to the nose cone, will be inside, and there will be an eye bolt bolted into it. So we will connect this thing not at a tape, but at the eye bolt. So that's the major change.
So how's the eye bolt being? Are you guys cutting, I guess, the tip off and having a metal tip with an eye bolt in it, or how is that eye bolt getting anchored?
Okay, we will show you that part. Just a second.
Okay.
그 검은색 아이고 말하는 거구나.
Oh, and also, like, while they are doing their own thing, like, would there be any like advice on fiberglass manufacturing by any chance? Because, like, honestly, I think one of our like pitfalls was like I just tried to do it myself with all these like YouTube tutorials, but like they are doing it so naturally, and like it just seems like the easiest thing in the world. But like, in practicalities, like we had so many trials and errors. So like, would there be any like advice in CFRP? I mean, like GFRP manufacturing, especially in like resin infusion.
So I guess most experienced guy that I know, his name is Jim Jarvis. Jim Jarvis is going to be at the Cup. He's in charge of the 2-stage rockets. He's flown his own personal rockets to 200 and some odd thousand feet. He's done 2-stage, 3-stage rockets, and he is by far the best filament carbon fiber layup expert that I know. And he has written a wonderful, I think it's almost 30 pages of a guide on doing fiber composite layup. And if you look up, his name is again Jim Jarvis.
Jim
And
Jarvis.
I think it's freely available on the internet. You can download it off of Google. But it was a design on his rocket that was called the number 4 and then carb, as in carbon, CARB, and then 4 carb yin, I think was YEN. And if you guys can't find that, let me know and I can hunt it down for you. But that is what I would call the Bible. It would be like you talked about the NACA's document on black powder and propulsion. Yeah, Jim Jarvis would be the Bible on carbon fiber layup. And that applies to fiberglass just as well. He talks about vacuum bagging. He talks about fin cans. He talks about all the challenges of trying to do various different types of layup. And he brought one of his rockets to one of our launches, and it was so light when I was holding it that I was like, wow, that's. But I could not get the fins to bend at all. He sets it down on the ground and steps on it, on the fins, and it holds all of his weight. And I mean, they just could not believe how strong it was. But again, he's done thousands of layups and has all this expertise. But definitely take a look at that. That will set you many steps ahead if you can follow some of his guidelines.
Okay, thanks
Very much.
And this is the eye bolt deck that we've talked about before, and there actually has been some problems with the 3D printer. So there's only one of them printed and it's not, we can't find it, so we are going to show you the model. And this small part, and we will put the eye bolt here at the.
So how would you anchor that inside the nose cone?
Oh, we will use a structural adhesive on epoxy on this part, and it will glue into the nose cone.
Okay, I would recommend if you're going to use 3D printing, and that's fine, just get a small piece of fiberglass or composite and put that on the front side of it. So that's your anchor point for your eye bolt. That way, if 3D printing has a neat capability or characteristic of shredding, you know, specifically, you know, because it's linear laid down, you're laying it down layer by layer by layer. But if you put a chunk of fiberglass behind it, and then the eye bolt with a big washer, you know, on the other side, that will create a lot of strength. Also, you may want to put some screws in through the side, some mechanical structure. So the epoxy is great, but understand nose cones get very hot out there in the sun, and epoxy loses a lot of strength when it gets overheated. Mechanical will avoid all of that. So I would do the epoxy and then add 3 or 4 screws into that to anchor it down even more.
Okay, thanks for the advice. We'll.
Yep, that'll work.
Yeah, thanks. Okay. And we were concerned about damaging the pyrogenic fire, damaging the payload. So we tried to separate the pyrogen combustion here. So that's one of the reasons. And to prevent tingling of the shock cord and electric wires like this, we used a CFRP tube to increase the electric wires, and that came out neatly. So that's the part. And the pyrogen deck will be inside 2 CFRP tubes to maintain their position. So it will go in like this, and this thing will come inside this tube.
Okay, so that should help guide it as it releases. Again, I'm looking at, you know, any pieces like those the little white electrical wire interconnects.
Okay.
You know, how if those were bouncing around, how easily are those going to disconnect?
So this thing is called a harness wire. So even if we go strength of it, it won't separate. But in case of parachute pulling out by the drag, this thing will separate. So yeah, I think that this is a suitable connection with the wires.
Okay.
Okay. So as I mentioned before, the pulling of the payload parachute will be stopped by this first tender descender, and after the tumbling ends and the rocket comes to a stabilized descent, this will separate by the signal from the avionics. And there is one tender descender here, but at the flight model, we will use 2 tender descenders, which is connected to a separate avionics for redundancy. So that tender descender will be like in this part, which is serially connected to the other tender descender. And the signal for the main pyrogen will be transferred by this wire, and this wire will be cut when the drag force is applied. So I think that will be okay with the operation. For the next part, the tender descender will separate, and this thing is very tightly connected, so I'm gonna just disconnect the carabiner. Yes. Okay. And this would be severed too. This thing too. Yeah, and the payload will come out then. And this is, I'm sorry about the quality of the boilerplate, but this has been thrown out of the car at the speed of like 50 miles per hour. So it's like, yeah.
Yep,
And
no worries.
stop. Thank you. Yeah, the payload will pull out the rocket drill, and this will deploy the rocket drill like this. I think that you'll notice that the drill part is a little short, but we will apply a separate tender descender from this carabiner to the parachute. So yeah, we forgot to add them when we were assembling this, but we'll make sure we'll do that. Yeah.
Okay, and you were saying that the main deployment bag that you have there, that's going to stay inside the rocket, correct?
Because another shock cord will be connecting this part and this part. So this main parachute will be inside the fuselage.
Okay, so it'll stay in there. Got it.
Yeah. And these are the tender descender keeping the main parachute from deploying. And as you can see, it is connected to separate electric wires. And we had some mistakes in getting the wires too long, and this will be adjusted. So there won't be tangling like this at the flight model. Also, we will put duct tape at this part, so even if it scratches the other structural parts, it won't cut off. So is this
Okay.
part? Okay, thanks.
So let's look at real quick. I'm interrupting the flow, but I want to look real quick at where are the avionics? Where are the actual your flight computers? Where are they housed? All right, so they're way down the other end.
It will be attached here, and right now we're assembling it here.
Okay. I just wanted to make sure that there's no chance whatsoever that any of those ejection charge or those devices that are being ejected out of the other side can affect that area. That area needs to be completely isolated from a pressure standpoint. So, you've got your what you're looking at right there. Is that going to be sealed epoxy in there, or I just want to make sure that, again, ejection charge pressures cannot sneak into that avionics bay and fool the computer thinking that it's hit apogee or that it's at 1,500 feet.
Well,
so that's
a good point. So we placed the avionics part very far from the pyrogenic part, and the pyrogen part is concealed with multiple decks. So the flames won't be we're not really worried about the flames, but in case if the flames come down here, we're going to apply duct tape around this bulkhead. So I think the flames will be okay.
Yeah, guys, I'm not worried about flames. I mean, dear God, that would be the worst case scenario. I'm just worried about pressure, because understand the environment for that avionics bay has got to be essentially identical to the environment just outside the rocket, meaning the barometric pressure outside that rocket where that avionics bay is needs to be exactly the same pressure. And what happens is with the ejection charges firing off, you're creating new pressure. And you just want to make sure that pressure does not make it into where the avionics is, because that's where you get false main ejections. When your apogee charge fires off, it overpressurizes your avionics bay, and that increases the pressure. And so with increased pressure, it thinks that the rocket is now back near the ground. And it's like, oh my God, I'm near the ground, fire off the main. So you'll see the main and the apogee charge fire off at the same time, or right after each other. And again, with a main popping out 10,000 feet, you understand the challenges there. So that avionics bay has got to be nearly fully sealed from any of those events occurring with the ejection charges. But there should be vent holes allowing it to have natural aspiration with the atmosphere outside the body tube.
Okay, that's a great point. So we were actually planning to drill a hole at this fuselage to, yeah, about this part where the avionics will be at. So the atmospheric pressure right outside the fuselage will be same as this avionics part. And maybe we'll try is applying a duct tape around this inside part is acceptable, or do we have to apply a epoxy or a rubber O-ring to maintain pressure?
It depends on whether or not that's got to come out. I mean, obviously you need to take the eBay out from time to time.
Yeah.
So, you know, from that standpoint, you just need to be very careful that when you're putting that in there, that you don't have any large gaps or holes like where wires go through. You want to protect that, and again, think of it, you know, logically from. I wouldn't worry about going as deep as an O-ring or anything like that, but you know, maybe a quick piece of tape around the thing might help it. But on what I'm looking at right now in the picture, in the video, you know, the bottom half shouldn't have anything. I mean, what we're talking about is all going to be on the other side, right?
Can you explain it one more time?
So go back to so that little section I'm looking at right there with wires and such. Is that there's no avionics or anything inside of there?
Yes, there's no avionics here.
The
Okay.
wire here is connected to a terminal barrier to isolate the avionics part from this recovery part. So yeah.
Okay, no, that's exactly what I'm looking for. Again, you have a very strong, good isolation between the avionics and the ejection charges, and that looks like you've done that already. Just make sure there aren't any blatant open holes, but the avionics area certainly should have something with a vent hole going to the that. So I think we're good there.
Okay, thanks. We'll apply a piece of tape, duct tape beneath here. Yeah. And there won't be any holes to vent
Okay.
hole. Thanks. So for the next part, when the rocket reaches 1,500 feet altitude, one of these tender descender will separate. Both of them will separate, and only one is required to make the next step possible. So if we think that the first tender descender activates and this got separated, the pull of the drogue chute will make the main chute possible. So again, the line here is way too short because we forgot to. Can you show them this one? Yeah, we forgot to apply a shock cord to this big carabiner to the swivel link that is connected with the parachute. So this part will be way long than as shown here. So yeah. And we were also worried about the tangling of the tender descender wire. So we applied this cable ties, and the wires go around like spiral shape, and it won't be that too messy about the tangling part. So yeah.
Okay.
And
All right.
okay, that was the final step. So do you have any concerns or questions?
No, I think you guys have a lot of work ahead of you from that standpoint, but you know, definitely is still a slightly different. I mean, Anita and I have seen hundreds of different ways to get dual deployment. We've seen something similar to this, but not quite like where you have almost a separate chamber for your tubes for the parachutes and such.
Oh, there's actually polycarbonate tube, which is transparent too. Okay.
But I mean, I mean, Anita, I think it potentially could work. There's a lot of opportunity for tanglement. I think that there, you know, could potentially address. I mean, that could occur with almost any launch. But I don't see anything else that's significant that requires significant change. What are your thoughts?
I would agree too. I mean, any, dual deploy, there's associated risk. I mean, this is definitely something new that we've seen at Cup, but I mean, it doesn't mean it's not gonna work. As long as you guys have thought about almost everything, which you guys have clearly tried to simulate, test, and even, improve on from what you found. I mean, I don't see any additional risk. It's just definitely something different. So it's kind of interesting to listen and learn. So
Okay,
that's
thanks.
my take on that one. Can you guys actually go back? I know this is your simulated one, but you guys actually showed us briefly, I guess your official payload. I know it's still in its process, but I would like to see it really quick again. I know you guys panned to it and then came back and then
Oh,
if
actually,
if
the
No,
develop
it's just a dummy, actually.
not at this room. It's developed at another place by another
So like
room, so we don't have access to it right away.
Okay.
mass.
So I guess my question is, I know that's the mass mock basically of it. What are you gonna make it out of in the end? Like its final material. I know it's still being developed, but you guys have to have at least a material identified.
Oh, the main component of the 3U CubeSat payload is structural steel to maintain the mass regulations. And we'll also be using laser cut acryl for the communication purposes. So we are still developing on the payload, but there will be 6 cameras, which will be filming the outer environment. And there will be also a COTS GPS module to track its location. And the bad part about it is like that the deployment bag will be tangled into the payload, but yeah, it was part of the recovery system. And if the payload doesn't come out until as a full form for the next few weeks, we will make a boilerplate the same shape as this, so there will be no concerns about the rocket regarding to the.
Okay. I just wanted
You guys have
to
a
know your
lot.
thoughts and maybe your time frame on that one, because you do have a lot going on.
Yeah.
Well, there's a
Yep.
separate person in charge for development of the payload, to be fair, but yeah.
Yeah, there's a entirely separate research team which is developing the payload, and unfortunately he is not here in the review site. So yeah, maybe we'll send you for more informations about the payload.
Yeah, if you guys send me, Andy, and your flyer record updates, it doesn't have to be another video, but like email updates with pictures, just to say this is what it is and this is what we're gonna have to do. Show us the updates as you guys keep, going with this progress, if you wouldn't mind.
Okay, we will make sure.
Thank you.
All right. Anything, I guess, anything covering everything. Any other last questions or concerns, Anita?
I don't
Maybe
think I have any other concerns.
Yeah.
If the team definitely has questions, we're more than willing to answer. I know you guys have some, and that's totally fine. So I guess we'll open up to you guys if you have additional questions or.
So for
Yeah,
our wiring from the avionics to the ejection charges, we tied the wires on this rod like this. And in regarding flight conditions, is this kind of wiring acceptable?
So when
I
you
mean,
say tie, I guess it's like a twisty tie, kind of like a metal thing, and you guys twisted it?
We twisted.
Is that
Sorry.
what did you guys twist on there? Like I can kind of see it, but like it glares, so it's
So the wires are on a spiral shape around the
okay, yeah.
and there will be tape. This is this is paper tape, but we will be using duct tape or zip
Or zip
line,
ties.
cable ties to.
I recommend zip ties. I would recommend the cable ties.
Okay, we will do
Okay.
it like cable ties. Thanks.
Yeah.
And regarding the shock cord lengths, what's the rule of thumb for choosing the appropriate lengths of the shock cord?
Well, you guys are doing some different capabilities here, some different options. Typically, the shock cord lengths between your apogee deployment and your main deployment, it should be about 3 times the length of the rocket. But because you're doing instead of separate ejection charges, you only have a single ejection charge, and then you have the tender descenders. So the tender descenders sort of take out a lot of the shock that would typically apply during a ejection charge event. So I would say the nose cone piece with the ejection charge is the only one that really sort of applies to that. So you want to make sure that when the nose cone flies off, you want to make sure that the length of shock cord between the nose cone and that permanent link, that would probably need to be, again, where it would stop, I guess, is what I'm talking about. When it fully pulls everything out, it's going to pull the deployment bag, that kind of stuff. Make sure that you have sufficient length on that one. You want to make sure it's strong enough that it pulls the parachute out, but you don't want it to have any ability to shear or to I guess, unanchor your nose cone or pull itself away from the main thing of the rocket. So I would say have at least 8 to 12 feet of shock cord for that.
We'll replace this to a much longer one, maybe 10 feet. If that's okay?
Yep.
Okay, thanks.
Thank you.
I did have one more question as we kind of were talking about it. So that nose cone is where everything's going to start coming out, which is fine. But are you guys using shear pins?
We were originally not, but we will apply a shear pin to the nose cone.
Okay, so you're gonna need probably like minimum of 2
Okay.
shear pins. So at that, out there at spaceport, you're gonna want to test that, but you're gonna need at least 2 shear pins. Most time I do 3,
Okay.
but 2 is probably about the minimum you're gonna get away with, so definitely recommend the shear pins
Okay.
on that one.
Yeah. We
Okay.
will do 2 shear pins. Thanks.
And once you do the shear pins, you need to retest all of your ejection charge to
Yeah.
validate that 6 grams is still appropriate.
Yeah, sure. Thanks.
Yes, we are aware of that.
All right, I have a little bit of a speech that I give to all the teams at the end. I'll ask you a couple of simple questions. Really doesn't apply to the rocket. It's more towards the team and the logistics of and what happens when you do get to New Mexico. Is there anybody on the team that has attended Spaceport America Cup before?
No, for all of us, this is the first time.
Okay, very good. All right, so let me start through the speech. So I guess number one, how many people from the team are going to be attending?
11 people. 11.
11 people. Excellent. That's a good sized team. We've had teams that had 3 and 4, and that was almost too small. And we have other teams that have 25. And that's, holy cow, that's a lot. But nonetheless, that's great. That's a great number. And again, appreciate you guys traveling as far as you are, because I mean, you're giving up like weeks of your time versus, again, Anita went to New Mexico State, which is sort of the hometown for the Cup. So yeah, her commute to the competition is like wake up and get in the car and just drive 45 minutes and she's there. So must be nice, huh? But that's part of the thing. So we do appreciate you guys significantly for traveling as far as you do. You guys and the Australians are the ones that we just like, wow, that's a long travel. So 11 people, everyone's paid the fees at this point, their Rocketeer fees. Is that correct?
Yeah,
That's correct.
Yes.
Excellent. All right. So how many people are going to be going with the rocket to the launch pad to do the preparation at the launch pad?
Maybe.
Two or three people.
Okay. Yeah, and we'll typically allow 3 or 4 people. So I mean, and to gain that experience, that's what we like to see on teams of 11 is you get to go down range one way or the other. So say the 4 people go out to the pad for the launch prep, and then maybe a different 4 people go for recovery, meaning going and getting the rocket. Anyways, anybody that goes down range on either one of those groups must be a member of the Tripoli Rocketry Association. So hopefully you guys have your Tripoli memberships already secured. Is that correct?
We do not. No, as far as I know, I think that we register it on site. Is that correct?
No. In fact, I would highly recommend you guys go visit the Tripoli Rocketry Association website. And anybody that's going to be either on one of those teams or heading down range needs to have a Tripoli Rocketry Association student membership. Okay.
So go to the website and register.
And
Does that involve any qualification, like testing or something?
Nothing like that. Nothing at all. It's just add your name, your address, but it is individual. So, again, if the 5 people or 6 people here on the screen, each one of you have to have your own membership if you're going to go down range. If you got somebody on the team that doesn't want to go down range, that doesn't want to be on either one of those teams, they do not have to be a Tripoli member. It's only $10 a year, but it provides $3 million of liability insurance. And that's big. Welcome to America in insurance. Everything has to have insurance. I mean, God, you sneeze the wrong way. Oh my God, insurance. So that is going to be required. So and it's $10 per person. It lasts a year, and they won't give you a physical card anymore. For the old timers, myself and Anita and some of the others, you get a physical card like this. Oh, come out of there. There we go. So I can show you my card. So there's my Tripoli card, and you can see it's got a little number 3 there, which means I'm level 3 certified. You guys don't need that. You just you'll get an email that comes back once you join that says, welcome to Tripoli Rocketry Association. Here's your student membership ID number. And so the number, there's my number up there. That's what we need when you check in. We're going to need that membership ID number so that we can validate insurance, and we will give you a badge, a special badge that has a Tripoli icon on it. That means this person can go down range. Without that badge, you can't go do to the pad. You can't do recovery. Okay. So I'm glad I caught you guys on that one, because that's kind of important.
Does that
all right?
U.S. citizenship?
No, absolutely not. It's a completely international organization, and so there are members from all around the world.
Thanks.
And hopefully someday there'll be some prefectures where they have some launch sites in Korea. That would be really nice. So we've started. There are tons of launch sites in Brazil. We just started some in Mexico. Turkey now has some launch sites that are Tripoli prefectures or clubs where you can actually get certifications. And so I know the challenges working with your government probably would be significant. Same with India and some of the others where, yes, we have a space program, but we're not going to let our students actually learn anything about rocketry by launching. No hands-on. You can't do that. Only the government can do that. It's frustrating for me that the United States can allow events like this where we have student teams launching to 30,000 feet, with these liquid engine rockets, and do it safely, and still these other countries are just don't want to do anything about it. So but times are changing. We're starting to make some inroads. Canada, who is very strict, now allows custom hybrids. So SRAD hybrids you can launch in Canada now, and that's changed the last 2 years. India is starting to break loose a little bit. They're thinking about having some new organizations come in, but I know Korea is a challenge as well. All right, so I'll keep rolling through my speech. Where are you going to be staying, in an Airbnb or a hotel? You mentioned a Motel 6, right?
Yes.
Okay, all right, and it's in Las Cruces.
Yes, it is.
Excellent. Okay. Most of the activities will occur in Las Cruces. The Monday registration, Tuesday convention center day, and the closing award ceremony is on Saturday. All will be in Las Cruces. Fairly easy to get to. Should not be a problem. If I guess on Monday I would there's a integrated master schedule. So if one of y'all, not on screen, but if one of y'all just jump on a computer and go to the soundingrocket.org website, there is a section for all the critical documents. So like the DTAG and your
yes.
rules and regulation documents.
Yes.
That there are other documents on there that are almost as important. One of those is called the Integrated Master Schedule. So if you keep scrolling down, you'll eventually get something that's called the Integrated Master Schedule. Wait until about a week or two before the event and then download that and print it. That means any last second changes that we made will be updated on that. That gives you a day by day, hour by hour type of activity list. So you won't miss anything. And that's the critical piece. You'll know Tuesday you do this, Monday you do this, Wednesday you do this, Thursday you do that. So you guys are planning to arrive several days early, which is fantastic. Really, the very first activity you have will be Monday morning, 10 a.m. You'll show up at the convention center in Las Cruces, which is very simple to get to. You'll start the process where you would bring your fully ready to be inspected rocket. So hopefully you completed all your repairs and the rocket's there. The team individuals will register. We'll give you badges and your shirts and patches and all that other neat stuff. And you'll have the ability to set up your poster area, your table inside the main convention center for Tuesday. And that's whatever posters you want to put up, whatever laptops with video presentations, whatever you want to sort of impress the judges when they come by and look at your thing. I definitely, if the team has team shirts, you want to wear those shirts on Monday for two different reasons. Number one, you're going to have a team photo. So we have a room set up specifically for the teams. You'll have your rocket in front of you. The team will be together. We'll have some banners about it, and we'll have some really nice team photos that you guys can have copies of as well. And so that's another thing. Your rocket will then, you can make your way into the inspection, the range safety inspection area, and begin the process of having the final range safety guys do their inspection. So basically what we just went through here, they're going to be doing it, but with their hands on it. So if they highlight concerns or issues, they will document it, and then you will have the remainder of the next couple of days, or the next 3 days to finish those repairs and get it re-inspected. Once you get sign off, if the range safety guys say you are ready to fly, they will have the signature, and life is great then. You start making your way, well, that the last thing that occurs on Monday, don't leave early. If you get all that stuff done, at 4:30, we're doing the large group picture. So you've seen that large group picture, and you don't want to miss that. That is on Monday. We used to do it on Tuesday, but it's changed to Monday afternoon. So don't miss that, or you won't be in the big picture. Once you're done with that, everyone's dismissed, and you guys can go out and enjoy Las Cruces and check out the shopping malls and the food and all the other neat stuff that's going on. There will be a what would you call it, a tourist bureau kind of group, a group of people that want to tell you all about the city and what you can do there, and museums you can visit. There is a rocket museum at White Sands Missile Range. Yeah, that's one of my favorites. I definitely do that, but also other neat places. Very, very neat. The New Mexican culture is really, really quite impressive. A lot of architecture, a lot of art and other things going on there too. And it's a fairly large city. It's a college town. I mean, there's a lot of students that are there, and a lot of modern restaurants and even some really, really old school Mexican traditional restaurants. But you can get any kind of food you can imagine there as well. Anina knows it even better than I do because she lived there, and I just visit a lot. Let's see. That is Monday. Tuesday morning starts very early. So I'd recommend getting there about 6:30 in the morning. And the reason is the opening ceremony starts at 7 a.m. That will go about 45 minutes, and they'll have some speeches and some blah, blah, blah. But there are also some important things for safety. They'll talk about what to wear out there, how to hydrate, how to deal with emergencies, those kind of things. So that's important. As soon as that is done, then you guys head out to your tables and make sure that throughout the day that you have somebody manning the table at all times, because the judges will walk by and they're going to want to know, blue shirts, you won't miss them. They have the blue shirts and they'll have notepads and they'll want to, take down notes about, okay, this is team 122 and da 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 da, and they'll start asking you tons and tons of questions. They're not inspecting your rocket for safety. They're looking at build quality, how well you communicate to to the questions themselves, not so much language wise, but if you have a good, strong understanding of how the rocket was designed and built, and you can clearly, I guess, explain that back to them. One of the problems they've run into, and they always is, they'll come and ask about a parachute, and the team will immediately do that's him, ask him, and I don't know anything about that. They don't like that very much. They want to make sure everybody on the team has a fairly decent understanding of what's going on in the rocket. Again, with language barriers, don't worry about it. If you got some folks that speak better English than others, I mean, you guys, trust me, speak fabulous English compared to my Korean, because I ain't got none. So, and I'm really, honestly, I'm very impressed by y'all's English. I mean, y'all are, I have had no hesitations or concerns understanding what you've been saying, and I appreciate that. Thank you very, very much. Let's see. That's Tuesday. You also have the opportunities to talk to all the sponsors. So the big companies. SpaceX won't be here this year because they're being pains in my butt. But that's Virgin Galactic, Blue Origin, all the big boys will be there. So you'll have the opportunity to grab t-shirts and swag and all sorts of neat stuff that's out there. We'll have a store for buying Spaceport America Cup memorabilia and such. If you want to buy shirts for like friends, neighbors, other people on the team that couldn't make it, then we'll have a store open that you can buy those. Patches. So here's, I don't know if you guys can see that. That's one of the ESRA patches. We'll have tons of those. We'll have a bunch of those in your bag when you arrive as well. So hopefully everybody on the team gets a patch and gets a t-shirt and that kind of stuff, some stickers. We'll have all those. But if you want to buy more, the store is available to do that. So that'll be on Tuesday. There will be food you can purchase inside. If you get bored and you want to send somebody out to go get food, which some teams do, like somebody went out and got pizza and brought it back. Convention Center will not let you bring outside food into the convention center. So the team essentially had their pizza and they had to go and get people. If you wanted to eat the pizza, you had to go outside and eat the pizza. You couldn't bring external food inside. That's one of their rules. So
It
anyway,
wasn't just food, it was also Starbucks. We had a
Oh my
couple
God, yeah.
people that said no drinks either. You have to drink
Yeah.
your Starbucks outside.
At 90
geez.
degrees Fahrenheit.
That's just pure evil right there. Not letting Starbucks inside. They should have a Starbucks inside. That would make everything fixed.
They're being rolled
Oh. All right. So that's Tuesday. Wednesday starts. That's the end of Tuesday. We're done. So 4:30, you'll pack up all your rocket stuff, and we're done with the convention center. We will not go back convention center. So all of your stuff gets loaded up. Talk about parking. Are you guys doing a rental car of some form or another?
rental. We're gonna rent cars.
Okay. So parking. When you pull in Monday for registration, you likely will not be able to park in the convention center parking lot. You can pull up, unload all of your stuff on the sidewalk or in there is a freight loading entrance. Once you're done with that, get most of the people out of the car and you guys stay. Whoever's driving the car, take it back, and there is a much larger parking lot about 2 blocks down you'll be directed to. Park there, a little bit of a walk back, but there's just with 1,800 students and 120 plus teams, this will be a record this year. So we're going to be jammed in. We'll be maxing out the capacity of the convention center. So the parking is good for about 400 people. So the parking lot will be full. So just plan on parking at the other parking lot. And then again, Tuesday, 4:30, bring your car back around, load it back up, and depart. You're done for the evening. You can go off and have fun and that kind of stuff. But Wednesday morning is the hour-long drive out to the VLA, the vertical launch area known as the VLA. That's at Spaceport America. It's about 45 minutes to an hour north of Spaceport America. That same website where the documents are on it, there are links to maps.
Yes.
And the reason that we do this, if you type in Spaceport America and try to follow the Google Maps straight off of Google or off of Apple or off of any of the other sites, you'll end up on a goat path on the wrong side of a mountain. And you'll be wondering, where in the world am I? And you may not even be able to get back to where you started from. Do not follow those map directions. They will get you lost. So print those out. Those won't change. You can print those out now, but have the copy of those with you. The first day you make it out there, you're like, oh, that was easy. I mean, that's not a big deal at all. But again, if you follow the Google map straight off, it'll lead you wrong. There is a border control checkpoint, basically, police officer type thing. And it's basically looking for, we're so close to the Mexican border and we've got the challenges with illegals and such down there. But as you're going through it, they're going to ask you one question, everybody in the vehicles. They'll ask you, are you an American citizen? And you'll probably say no. And so they'll want to see your passports and IDs, similar to like airport scenario. They're going to know. I mean, they're going to run into 120 other teams going out there, so they're going to know y'all are headed to the spaceport. Just answer whatever questions they have. They're not going to, they're not going to pull you out of the car. We're not like that. They are looking for very specific things. Illegal drugs and those kind of things. I've been through that checkpoint 25 times. And I've never been questioned on anything. But they do have drug sniffing dogs that they may walk around the car, that kind of stuff. If they ask you to open up a window or open up a door, just comply. 100% comply. You should not have any problems at all. They're going to see if they see your spaceport badges that you're wearing around your neck, they're going to know exactly where you're going. So there shouldn't be any problems with that at all. And I think from that standpoint, you should be in good shape. If somebody forgets their identification, and I'm going to say this for the entire event, being that you're not from the United States, so you don't have a driver's license, a ID, I guess, for that, make sure you carry those passports with you or have them very easily accessible at all times. Okay. Just in case, it doesn't matter what, but if you forget your badge, the badges that go around your neck for the cup, that's bad. Security guys will not let you in. Even if you show them passports, they don't care. They want to see the Spaceport America Cup badge that hangs on your around your neck. They will eventually let you in, and then you're gonna have to go find me, and then I'm gonna have to go find the badges, and then I'm gonna have to verify all the stuff, and I'm not gonna be happy. So don't lose your badges and don't forget them. Do whatever you have to before you leave every morning. Have one person just go around and like, do you have your badge? Do you have your badge? And again, the checklist. Always go through create a checklist so that you don't run in those scenarios, because we could very easily say, turn around, go back and get it, come back. And that'll suck. That would be terrible. The road out there is pretty easy if you follow those paper maps. Once you pull off the Interstate 25 onto the Spaceport America Road, it's a good 30-minute drive on that road at least. And it's 45 miles an hour, which to me, it'd be easier for me to just get out of the car and run because it's so slow. But I'm notoriously for driving faster than I should. The cops will be out there. You don't want a speeding ticket. I can tell you exactly last year, and Nita's like, God, I've heard this story so many stupid times. Driving there, curves all around. So you're taking turns left and right all the time. And I was going 65. So I'm going 20 miles an hour faster than the speed limit. So, probably similar to y'all's highways, you do that and the cop catches you, you're going to get a ticket. And so I'm shooting around this corner. There's a cop car sitting right there. I'm like, oh, I'm done. It's all over. So I just, he didn't even turn on the lights yet. I just pulled off to the side of the road, and I'm waiting, and I never see any lights. The car never moves. I'm like, what in the world's going on? There was no cop in it. He just parked his car right there to scare the poop out of us. So, I'm like, God, okay, pull off and driving. So 245, guys. It'll take you a little extra long to get out there. You'll notice cars shooting by you doing 65, 70 miles an hour. Let them get the speed tickets. Be careful on that one. You don't want to have to deal with that because that can be painful. The same thing with what I'll call team drama. And this is a general warning for all the teams. Had 5 or 6 things occur last year that woke me and all the senior ESRA staff up in the middle of the night. Team drama. Let's see, good example. Girlfriend boyfriend fights, and the boyfriend broke up with the girlfriend, and the girlfriend wanted to kill herself. That was bad, and cops are called, ambulance is called, and then if it makes it to the police department, it will make it to Spaceport America. If it makes it to Spaceport America, if ambulance, anything like that goes to Spaceport America, it's going to make it to us, and we will get involved. So if something happens, and accidents do happen, we've actually had car accidents with student teams before. Just be careful. Don't do anything crazy. Don't get out and go drinking in bars and starting bar fights or anything like that, because we'll hear about it. Again, I trust you guys, but don't create any opportunities to get booted out of the cup, because that's not fun. And I like sleeping at night, because the end of that week I'm about dead. I know Nita understands too. You guys will be exhausted as well. The weather out there can be nasty hot. Can be. Last year was nice. I mean, the hottest day was 95 degrees, which is wonderful. But we did have some rain last year, which created mud. So that was some new challenges we never had to deal with before in the desert. This year could be a more traditional temperature of 110 plus degrees, and that will absolutely kill you. That'll drain the life energy out of you. Clothing is super important. Sunburn, I wear long sleeve shirts, pants always. No tank tops or sleeveless shirts or shorts. No sandals, bad. You want to do tennis shoes and or hiking boots. Hiking boots are great, especially if you're going out to go recovery. There are rattlesnakes, which is a very poisonous snake, not fun out there. So if you're having to look under rocks or places that rattlesnakes would like to hide, be very super careful with that. If you see one crossing the road, you will from time to time. Not something you want to play with. You just let them cross the road. You go the opposite direction. And so if scorpions, that was the other one I could not remember. Scorpions. Again, boots and tennis shoes will protect you from scorpions. You're not going to die or anything like that, but it will hurt. And they even have tarantulas at night. If you stay there when the sun starts to go down, you'll see 10,000 little beady eyes out on the desert as the as the tarantulas start to come out. We actually camp out there at night, and we'll be sitting there in the tent, and we'll have 2 or 3 of them come up, and they're just curious. They want to see what's going on, and they walk right in the tent. And when you start talking about a furry spider, about 4 inches in diameter, good times.
There's so many things they're just trying to kill us.
So that's Wednesday, Thursday, and Friday. Hopefully, you guys get a sign off fairly early for your range safety, so that you can fly as quickly as you can. If you get sign off, let's say on Tuesday or Monday, fabulous. I would try to launch on Wednesday, the first day that you're out there. You get bonus points for launching on Wednesday. We don't open up the range until 12 noon. We allow you to set up. You'll be given a 20-foot by 20-foot area for your team. You'll need a table, chairs, whatever tools you need. You probably want to purchase a canopy from like a local Walmart or some type of store. Check with the Canadian guys. They'll know what to bring. They've done this before. But usually a 10-foot by 10-foot overhead canopy to protect you from the sun. So, take that out, get it set up. At night, it gets crazy windy, so you want to take the plastic cover, the cover off of the canopy, so it's just the frame, and then stash that somewhere that it doesn't blow away, because it can get crazy windy out there too. If it's not the sun trying to get you, it's the wind trying to get you, and every once in a while I have the rain try to get you. So if we're lucky, all the stars will align, and we'll be able to launch rockets every single day. But that doesn't happen always. So you got to be prepared for those. Launch as early as you can. If you're able to launch on, say, Wednesday, and you're like, nah, let's wait till Thursday. Well, Thursday you could get rained out. Friday comes rolling around. Everybody's trying to push for Friday. You never know what's going to happen. You might run into a situation where you don't get if you don't launch potentially until Saturday, you have a high probability of not launching at all. So that's why we always say we stop the launches at 12 noon on Saturday, because we need the rest of the time to tear down and clean up. And then we have the closing ceremony. Please don't miss the closing ceremonies. A lot of teams are like, I'm so exhausted, forget it. I just want to go take a shower and take a nap. It's embarrassing for everybody when we announce, and you could win an award that you had no idea, team sportsmanship, or you could win one of the altitude accuracy awards. You could win all sorts of stuff that you weren't even aware of. And when we announce, hey, team XYZ, come on up, and no one's there, it's just, yeah, it's kind of embarrassing a little bit. So again, plus you get to hang out with all the teams, and it's a pretty fun thing. You can buy more swag. We'll have the stores up and go in there, and it's a good time to hang out in air conditioning with all the other student teams as well. So and then that's it. Once the closing award ceremonies are done, you guys are free to do whatever you want, and then hopefully safe travels home. Those type of things. So we will inside that document is that reference page, the website I told you about. There's also proper clothing, which we'll go through. Last thing was hats, and make sure it's not just a baseball hat. You want something that'll cover ears and neck as best as possible, because sunburns suck, and you will get a scorching, nasty one out there. And if you get one on the first couple of days, you'll just be miserable the rest of the time. Drink tons and tons and tons of water. Anita will hunt you down. It won't be pretty if you're not drinking enough water. So, Anita, tell them what you typically do when you were working with your team.
So I was in charge of, for 3 years, about 23 people on our teams. We would take about 10 cases of water roughly a day, because they're going to tell you at competition and safety first day, 1 liter an hour of water. You are responsible for your team and each other, just like everyone out there. If someone is showing signs of dehydration, dizzy, headaches, slurred speech, all of it, make sure they're going to sit down, water. We do have medical out there if required and needed, but take care of each other. You are each other's lifelines. So tons of water, Powerade, Gatorades, all of that. Would bring coolers. There's food trucks and vendors out there, but as a team, you're always going to want to work for that opportunity, to launch. So I would bring snacks. We come Sam's Club, that's in Cruces, or even Walmart, Nutri-Grain, chips. I'd actually make sandwiches for all of them, stick them in the coolers, and we had all of that. So we were prepared for anything. You guys, I would recommend that too, but your water is your lifeline. Yes, you want it cold, but sometimes getting water in you is more important than if it's hot or cold. Sometimes you just got to drink it, whatever it is. I really recommend the drink packs. I actually have them. I already took them when I was in Las Cruces a couple months ago. Liquid IV, so they're like electrolytes that you put in the water and you shake it. We would always make the team take it in the morning, drink it together in that 16-ounce water bottle, and it really does hydrate you throughout the day. Before and after, I've noticed a huge difference, and it just keeps retaining the water in your body. But always tons of water. Electrolytes are your best friend out there. Light colored shirts, long sleeve shirts. I mean, you think long sleeve, it's hot. No, light gray. We would always have team launch shirts with them. And I've seen through years, teams have a black polo out there. That just cooks you even more. So stay away from those dark colors. even one year they recommended, you know, bring a bucket and you're going to drench each other. So we'll actually take, you know, like a bucket of water, dump stuff in it, you know, our hats. Sometimes they give you cooling towels, just anything so you're hot, your head gets really hot. That's where you're gonna get that weird headache, that dizzy. We would actually, there was one year a judge had that like a spray water thing, you pump it up and you spray the water. They were spraying everyone down. If you were hot and you didn't feel the cold, that means you were already dehydrated. So there's levels of effect of that, but do pay attention, and tons of water is your best friend out there. But yes, you are responsible for the waters and all of that. So make sure you plan accordingly, depending on how many days you're going to be out there at launch site. Okay.
So we have enough water.
Yeah.
So the launch areas open up at 6 a.m. So don't try getting in before then. There are security folks on site that will be checking badges, so make sure you have your badges with you. We typically will allow teams to stay as late as basically sundown. When it gets dark, it's time for you to leave. From that standpoint, that's usually 7:30ish, somewhere around there. But there will be a live stream. So for all the folks that are back home that want to see what's going on, we will have the event completely live streamed. We spent many thousands and thousands of dollars getting video equipment set up for it. So if your team has someone that's good with digital media and maybe wants to create a 15-second or 30-second long introduction video, what you would see maybe at a soccer match or some other where they introduce the players, you know, as they're, you know, number 23 for such so and so, Steven, da da da. If you guys wanted to do something like that, we will play it. So when your team is headed out to the pads, we want to show the world, you know, by gosh, it's, hey, there goes another Rocket team. No, we want to, you know, we're going to give them metadata about, you know, your team, where you're from, what category you're competing in, some details about your rocket. We'll give them that kind of stuff. But if you have your own video where it's y'all sort of introducing yourselves, that's awesome. We love that kind of stuff. And we will just say, hey, we'll let them tell you about their team and play that video as you guys are making your way out there.
Okay.
So if you guys can do it, I know you got 1,000 other things to do, but that's an opportunity if you're curious. So let's see, what else am I missing? Anita, anything else that you can think of?
I think we covered everything, honestly. Did the whole spiel, we got everything in there. But please do keep us updated on your progress. We'll work on, you know, that tube here and getting it sent to cruises. So please keep us updated. And that's all from me.
And
Good job,
at
guys.
the end of this, send me the link to the video recording so I can get that posted as well.
Okay. We will do
All
that.
right. Thanks, everybody.
Thank you. Thank you for your valuable time.
Very much.
Absolutely. Good luck. Take care.
Take care.
Nice day.
Bye.